with an M in the middle of it. And the last thing, a light bulb, is going to be a circle with an X in the circle. Okay, so those are the electronic signals that you're going to be seeing in an electronic ignition manual. Okay, so now you're familiar with all those. That'll come back to you as a handout, so just be aware of that. Today, most manufacturers are using one form of electronic ignition or another. Most of them have gone and used IPI systems, intermittent ignition systems. I don't know that there's any direct spark ignition systems around anymore. HHT, I think, was the last holdout on that. They had them up until a couple years ago, and then I think they did away with them also. Direct spark ignition, we'll talk about it a little bit later, but they have some particular hazards associated with them, so I think everybody's kind of moved away from that. There are a couple of them that are using millivolt thermocouples and thermopiles for their flame recognition on electronic ignition, but again, I was going to say far and few between. I guess that's probably not quite true because Maxi-12 utilizes it 100%. Okay, some of the other manufacturers are using it also, but they don't use it on the same scale as what Maxi-12 does. Anymore, the understanding of electronic ignition is a whole lot better than it was 5, 10 years ago. Okay, I guess people are just getting used to it. Like I said yesterday, personally, I'd rather work on an electronic ignition fireplace than I would a millivolt fireplace. Okay, for me, it's more rational. Okay, the steps on it are much more rational. One good thing, and I'm going to talk about this later, but while I'm talking about this, better understanding, one good thing is most of your major manufacturers of valves have now come out with the orange wire for the pilot, green wire for the burner. They call it EV1 on the controls, EV1 and EV2. Everybody's doing it. It came out, SIT was the first one that started doing that, and some of the others had different colored wires and didn't designate the valve posts, but now I think all of the major manufacturers, SIT, Dexton, and American Flame, they all use EV1 and EV2, orange wires, and green wires. There's one Dexton model, and when we get to it, I'll explain that to you. There's one Dexton model that uses yellow instead of orange. So it's yellow instead of orange, but the green wire is still the same. And they still designate EV1 and EV2. Like I said a little bit ago, intermittent pilots, IPIs, are definitely the most common types of flame recognition used today. Everything we're going to be looking at uses external power. Some of that is the primary source of power, others is backup power. Okay, so on that one there, just have to be careful with that. And have battery, what they call battery backup. It may not be a backup, it could be a primary source. Okay, so it may or may not have a control module. That's even with the IPI system. There may or may not be a control module there. And the shut-off is either thermocouple / thermopile or flame rectification. And I just want to talk about flame rectification for a brief second. Today, there are some manufacturers, and one that comes immediately to mind is SIT, that uses the pilot flame for conduction of electricity, but it's not true flame rectification. True flame rectification is rectifying an AC signal to a DC signal. And with SIT, many of their systems now are bringing DC current up to the sensor, and so consequently, it's not true flame rectification. But we'll talk about that when we get there. Okay. Transformers can be AC out of the wall to AC current, or it can be AC out of the wall to DC current. So just be aware that when we look at transformers, the best way to determine what you got is to look at the side of it. And again, I'll show you that a little bit later. I got a slide of that. The first versions of electronic ignition were 120 volts, and they were stepped down to 24 VAC, volts of alternating current. I have 24 volt systems anymore. It's been a while since I've seen one out in the field also, so don't know if they're still around, but maybe. Probably not though. The old ones wouldn't operate power outage because they did not have a battery backup on them. Modules, I don't know, maybe some of you were around when they first started coming out, but modules were had a limited warranty on them because they would go out so quickly. You know, every 4, 5, 6 months you were replacing modules. Okay, so that issue has gone away, thank goodness. Back then, some modules had grounding issues. Grounding issues are an issue today. You know, when we talk about, I said about the testing 3 planes of ground, that's always a good idea to do, because if you have any grounding issues, everything that I talked about today is out the window, because you get all kind of weird things happening with grounding problems. Okay? And at the time, were not generally understood. The second gen is what we're looking at now, and they're just a whole lot easier. The second generation kind of came around as a result of the Department of Energy. I don't know how many years ago, several years ago, Department of Energy tried to do away with standing pilots. In fact, they mandated that the Hearth industry could not use a standing pilot anymore. Fortunately, the industry sued DOE, went to court, and won the court battle. Okay, that was back. Actually, it was back under the Trump administration, the first Trump administration. Okay, so they lost the battle in court, and they reinstituted standing pilots. Consequently, millivolt units didn't go away. Otherwise, they would have eliminated standing pilots. Most of your millivolt units would be gone. Okay, so they tried that; it didn't work. Thank goodness. And anyhow, but they still pushed for electronic ignition, and that's why we got so much of it today. And it does reduce operational costs. By the way, just as a point of reference, I don't know if you've seen this or not, but one valve manufacturer now has a millivolt electronic ignition valve out there. So it does not have a standing pilot on it. It has a IPI type of system, but it's still millivolt. It still runs off of thermocouple and thermopile. Okay, so haven't seen many of them, but there's one manufacturer that has that. The operating voltage on this is typically going to be somewhere. It's going to be 3, 6, or 7 volts of DC current. It's going to be the operating voltage, except with the operation of integrated modules. On the IFC, the top of the module is 120. On the Dexon, it's over on the left-hand side. So they keep all of the 120 in one area, and the rest of it is lower voltage. So the 120, that's for driving the fans, the lights, combustion fans, anything like that. Okay. On most of the electronic ignitions, they don't use the thermoelectric power to open or close valves. I said on most, but again, Maxitrol is kind of the oddball out. Okay. Most of them will have control modules. They said receiver. Receiver is what Maxitrol calls their module. Okay. It acts the same as what every other module works like, except they calls theirs a receiver. I guess they call it a receiver because the thermocouple energy comes to the receiver. So anyhow, we'll talk about that when we talk about MaxiTrol. Most of them are VAC valves with PDC backups. I said most. Okay, MaxiTrol is not. If you hook up a MaxiTrol, it's going to work off the DC current until the battery's died, and then it switches over to AC. So it's a little bit back again there, a little bit off pace with the other stuff. Okay. Sounds like I don't like MaxiTrol. Their equipment is pretty bulletproof, but they're just so strange, you know. So normally, like I said, step down to 3, 6, or 7 volts, and the power coming from the battery pack, I'm sorry, not the battery pack, transformer is matching whatever the battery pack is delivering. And I just kind of covered that first one and stepped down to those voltage ranges. There is anymore, I think the last 4 or 5 years, they came out with a continuous burning pilot. Again, we went to DOE on this, and the industry went to DOE on this, and they won the battle of getting a constant pilot switch on our IPI appliances. And the reason for that, and the reason that we won that battle, was being able to keep the vent stack a little bit warm. Okay, DOE didn't give a rat's butt about condensation on the glass, but they were concerned about the fact that if the vent stack wasn't heated, you got a smothering flame that may not hit at night because it keeps smothering out. So they agreed for a constant pilot switch. The constant pilot switch has a 7-day limit on it. So if I have a IPI fireplace in my home and I have a CPI switch on them, if I have it set on constant pilot, okay, if I go on vacation and it's more than 7 days, the pilot flame will shut off. Okay, when I come back to the house and I turn it the first time, it goes to IPI to ignite the system, and then it goes back to CPI, and the clock starts all over again. Okay, so if I'm out there and as a homeowner, I'm out there and I light my fireplace today, and then I don't light the thing until Sunday. At Sunday, the 7-day clock starts again. Okay, so it's a running 7 days, and it always starts when I turn it back on. Okay, so 7 days today, I started tomorrow, 7 days from tomorrow. If I started 6 days from now, 7 days start. That's how it goes. Okay, that's how the thing works. Okay, so that's what the relay inside of the module does. Okay, so there is a relay in the power when the power out. The relay switches from DC. I'm sorry, AC to DC, except with MaxiTrol. Okay, so intermittent pilot IPI ignites the burner. Ignites the pilot, followed by the burner. Okay. Except for continuous burning pilots, when the burner or the pilot goes out, the entire system shuts down. When we talk about proving the flame, we're going to be proving it either with the thermocouple and MaxiTrol or with flame rectification on all the other IPI systems. Okay, so there's 2 different methods of proving the flame that we're going to be looking at. Most of all, it says control will initiate the ignition system. Most of the newer IPI systems only has 1 attempt for ignition. Okay, it will attempt for 90 seconds and go to shut down, drop out. Okay, so be aware of that. It used to be in some of the other systems, it would be 2 or 3 times attempting for ignition and then go to drop out. But anymore, it's just the 1 90-second attempt. so they don't go into all these alter reignition systems. So it's not like we used to. If the flame blew away from the sensing rod, the thing would shut down, it would wait 30 seconds to start up, and if the flame was still going around, blowing them up, trying to talk too fast, trying to blow the pilot away from the sensing rod, it would come back on. But then there's no sensing there because it's blowing away from the sensing rod. So then it cycles off. Then it tries the light again. And it will do that X amount of times until it reaches lockout mode. Okay? So now we don't see that. If it moves away from the pilot, it has a 4 second time span to reestablish a flame. If it's still blowing away from it or it was extinguished or what else, then it shuts down 1/10. Okay, so the system is not going to recycle like it used to. Okay? Most systems have a one-time 60-second trial. Some of that's 90-second trial. When it's locked out, the system has to be reset or it won't relight. Okay, a lot of the systems now have a shorter span for taking it out of lockout. SIT says 2 seconds. I have yet to get it to work in 2 seconds. Okay, maybe 10 seconds it does, but not 2. At least I could get it to work in 2. Okay, so it's better than the old ones. The other ones are 30 to 60 seconds. In fact, the EFCs that I have back here, they're going to be that time span somewhere between 30 and 60 seconds to get out of lockout. Okay. So to take it out of lockout, you take the thing out of the man position. You used to be able to pull it out of the walls, thing out of the walls, circuit out of the wall, and then plug it back in, and that would be a faster way. But you have to make sure that the power is turned off to the control module. DSIs, the reason you don't see these anymore is they spark directly to the burner. So as soon as the thing starts to spark, gas is released to the burner and the spark ignites the burner. Well, you can see the problem with that. If I have obstructed ports near the spark igniter, I'm going to have delayed ignition. And if I have gas on the burner as opposed to a pilot, I have a heck of a lot more. So there was more delayed ignitions with popping of doors and blowing glass out and all of that stuff. So they moved away from DSIs. You still see this in other parts of the industry, you just don't see it in the hearth industry. So that system has not been eliminated. It's just not used in our industry anymore. Okay. So the picture over there to the left is a DSI. You can see the spark igniter is right above the burner. When the valve releases gas in the burner, it's relying on that gas to be ignited by the spark igniter. Like I said, the problem with that is if it had any kind of debris plugging up those ignition ports in that area, there's a lot of gas released behind the glass door, so lots of delayed ignitions. The one over to the right-hand side, IPI, you can see there's only 3 components on it. I have my directional hood, I have my spark igniter, and I have my sensing rod. Okay, the sensing rod is typically the smaller of the 2, but not always. Okay, I can't say that's always the case, but generally the smaller of the 2 rods is the sensing rod. The bigger, fatter one is the spark igniter. The secondary side of the valve works exactly the same as the motor volt systems. The only thing that's happening on this, ladies and gentlemen, is we're using different voltage. So instead of using low voltage now we're going to be using 3, 6, or 7 volts. Okay? So that's the only difference. And that's one of the things you need to plant in your mind when you're working on these things. Voltage is different. Electricity is just electricity. All we're doing is using a different voltage on it. Okay? Okay, now the way flame rectification works. Okay, this is true on both HSI and DSI systems, but I'd like to focus on the DSI systems, obviously. Whatever my spark igniter, no, I'm sorry, let me take that back. Whatever my flame sensor is sending the signal to has to be 4 times larger than the sensing rod. Okay, if I don't have that disparity in size, flame rectification doesn't work. Okay, and I'll explain why here in a minute. Excuse me. So on an IPI system, the pilot is 4 times larger than the flame sensor. Okay, the flame then proves the signal back to the module. Okay, now the way this thing works is this. And this is just a crude schematic of what's going on. Up here I have a transformer with my AC power. I have 2 wires coming down to that to my module. Some of them will take one line from the transformer and run it over to my controlling device. Okay, but majority I brings both wires to the module. I have a controlling device over here, 2 wires to my controlling device. I have 1 wire that's going to my igniter. I have 2 or 3 wires going to either 2 or 3 going to my gas valve. On this one here, I have 2 going to the valve itself and 1 going to ground. That works also. I have 1 going over here to my flame sensors, and my pilot also is grounded. So I have a ground from the valve, a ground from my pilot. Okay. So now the system goes like this. My controlling device goes into man position, sends a signal down to my module, say I want heat, and when that happens, my spark igniter starts sparking, and I get a microamp charge over to my sensing rod. Okay, the microamp that's coming over here is so small and so insignificant, it cannot go over an airspace gap. It doesn't have enough oomph to get past that airspace gap. So consequently, it just hangs out at the end of my sensing rod. Okay. This one here, the voltage on this is about 2,500 volts. So consequently, I just spark across that airspace gap. Okay. So that's what the first thing goes on. So now a millisecond later, a signal is sent from the module to the gas valve to release gas to the pilot. And when that comes up and engulfs that like that, now my flame conducts that microamps through the flame to my pilot hood, and it goes from AC current here, true rectification, goes from AC current here to DC current here, down to my ground, over to my module, up to my module, and the module says, I have DC current, that means I have a flame, and I can turn my burner on. Okay? So it's kind of an interesting system. Kind of interesting. Okay? So now, as long as I have a DC current back here, everything is happy. Okay? So here's what I'm trying to designate here with that little broken line, small broken line. So that's my AC current starting out over here and being rectified from DC current over in this side here. So in that short little space of the pilot flame, my current is being rectified from AC to DC. Okay? And then my DC is going down here over to the module. Now, this is what I was saying, that some units are not true flame rectification, because on SIP, they use DC current. So they're bringing DC current out here. So let me go back a couple of slides. At this point here, it's DC and not AC. Okay? So there is no flame rectification. When the flame comes on and it involves this sensing rod, it's the DC current that's gone across there, and DC current here is going back over the module. It's still DC current. It's just not being rectified. Okay? So direct current is just that, direct current. You know, it goes one way. It does not come back. AC current goes back and forth. Okay? So now, if you think about this, and I'm not trying to spend a lot, inordinate amount of time on rectification. But if you think about what I'm saying, is AC current is a sine wave index, and remember what I said yesterday, it cycles 60 times per second. So it's going back and forth like that 60 times per second. So now when I have one object that's 4 times larger than this one, guess what happens? My electrons are the things that are moving, right? So the electrons are attracted to the larger object. So the back and forth that's taking place in here is still taking place, but the electrons are attracted to the bigger object that's 4 times larger, and they stay there instead of cycling back. So because it becomes directional, only going one way, that's what rectifies the signal from AC to DC. Now, does any current go back to this thing as AC current? The answer to that is yes. It's not every electron goes over to the bigger object, but most of them do. Most of the electrons go to the larger object. Some of them still go back to the smaller object. So I still have AC going back to my spark igniter, but then it's recycled back over to my larger object, and it just goes back and forth until it's completely rectified. Okay, so the flame, all that flame does is take DC current down to my module. And if I don't have DC current in the module says I don't have a flame. Okay, so I have to have DC current. Okay, so when we test our 3 planes of ground, what we're going to be doing is we're going to be checking the pilot to ground, the valve to ground, and the module to ground. That's our 3 planes of testing that we're going to be doing. Okay, so if we have an issue and we're troubleshooting something, we can't determine what it is, we might want to do that test. I don't know if we want to do it all 3 anytime we're looking at the appliance, but occasionally, if we can't figure out what's happening, you'll want to check those 3 planes of ground. You want to make sure the pilot's grounded, the valve's grounded, and the module's grounded. Okay, all those things. So the way this all works, like I said, on the 4 times larger thing, that's my sine wave, and what effectively takes place is I lose the bottom part of my sine wave when it's going over to my larger object. Okay, I still have some. I probably got to put dotted lines on one of those things because one of them still has energy going back to the smaller object, but not very much at all. Maybe it's that upper line over there on the far right hand side. Okay, so that's flame rectification. In the event that my flame blows away from my sensing rod, most manufacturers now give us a 4-second leeway to reestablish the flame on the sensing rod before everything cycles off. If that 4 seconds is exceeded, then the flame goes out, and it does not need this anymore because it only tries one time for ignition. So the old one used to try a second time for ignition, and it would typically relight the thing and start cycling. Then it would cycle off, cycle on, cycle off, cycle on, until you had 2 or 3 times of attempting for ignition. Okay? So flame rectification. So it's one of those things you and I need to be, we don't need to be aware of how this particularly works. You do need to know that it's going to be DC current going back to the module. That's what you do need to know. Okay? So just be aware of that one. Anything else in that, you can just impress people what you know. This is a little 24-volt transformer. Like I said, they're very rare anymore. I won't say they're not around, but they're very rare. Okay. This is today's transformer. This just so happens to be a Dexon. This one here is going to take 120 out of the wall and convert it to 3 volts of alternating current. This is not going to change the voltage from AC to DC. Yeah, AC to DC is going to maintain AC current. throughout the system. So that one there is going to still at two ends there. It's going to be AC current. Okay, electronics controls. So modules, they control everything. They control sensing of the ground. They control whether the appliance is going to go on and off. It's going to control the presence of a flame. It just controls everything. Okay, so everything that is on that appliance is going to be controlled by the control module. Okay, what I'm going to do now is I'm going to go through all of the various controls and have a look at what they look like, tell you a little bit about how they operate, because they may operate a little bit different. There is absolutely going to be differences in voltage requirements and ohms requirements between Dexin and SIT. On Dexins, I might have different voltages and ohms on the particular valves. So we'll go over that when we talk about this. Okay, so this is the Dexin GM6K. Everybody tells me this is a green module. It always looks black to me. Okay, but if you say it's green, if you see it as green, it's green. Okay, this is a pretty simple module. It's very well labeled. Up here I have my ignition spark. Oh my gosh, I'm going brain dead here. My sparking pattern and my flame sensor. Okay, this here is very well labeled. The black, orange, green. That's my valve. Those three are going to my valves. Next to them, I'm going to have two brown wires coming out. The brown wires are going to go to my controlling device. And the last two of these are going to be my transformer current. No, this is going to be my battery current coming into the module. So first the valve next to the switch, and the last two is going to be battery power coming to the module. Okay, these bottom two are my AC adapter coming up to the module. Okay, this is working off of a 3-volt system. So I got two DC batteries on this one, and down here I have a transformer taking it down to 3 volts. Okay. This one here is GM6K also. You can see this one is square as opposed to this one. This one here, the difference here is this one has a timer on it for the CPI switch. Okay, this one does not have a CPI switch on it. Okay, so that's the difference. The pins are exactly the same. My AC is coming in the same. Sparking motor, sensor, and ignition is up the top. Okay, this can be used on all of the valves that we're going to be talking about. All the 3 valves that Dexin makes. So this can be used for the 6003B, the 6003V, and the H3V valve. Okay, so there's 3 different valves that you may encounter from Dexin. They all work off of GM6K. Actually, they work off of any of the systems. Okay, this one is the GM8K. Okay, a little bit different. Over here, we have a igniter and sensor. Down here, we have these 4 pins there. That 4 pins there is for exterior modules. Okay, this is not an integrated module. Okay, they put this on here, and we have two different models, external modules, auxiliary 200, auxiliary 300. Which enables us to, on the 200, we can use that to drive one 120-volt system. The AUX 300 is 2 systems. So if I have a 200 attached to this, I can use it for fans or lights. If I have the 300 system attached to that, I can do both fans and lights. Okay. This has an on-off switch that we need to be aware of. So there's just like some of the old remotes. So it's on-off remote. That's how this is also. There's also a button right here. You may or may not be able to see it from your seat. That button here is for propane natural. Okay. The button does not do the fuel conversion. So that does not do anything to convert the gas going to the appliance. The only thing that is doing is signaling to the module that I'm using propane or natural gas. Doesn't do anything more than that. Okay? Strictly to the module only. Anything else is out the door. Okay? These 4 pins right here are for flame modulation, and these are from my controlling device. Now, interestingly enough, this one here only has one ground wire going up to it. And to be honest with you, I forget what's what. There's still 3 pins for the valve and 1 for the controlling device, and then 2 for the battery. And what they do on this one here, the one leg, the hot leg from the battery pack, you have to take up to your controlling device. Okay, so that's where the controlling device gets its power. Okay, and then like I said, these are for modulation. Yes, sir.
The GM6A you said works for all Vexen?
It works what?
GM6A works for all Vexen?
All Vexen valves?
Yeah.
Yes, sir.
So then we should pretty much have that one on trucks. For Vexen.
Depending on what you're doing, yes. That's going to be the dumb module, or the dumber module. That's like that is equivalent to the SIT DFC control. Okay, so if you look at the digital fireplace control for SIT, the 6K is equivalent to that. This one here is kind of a bastardized module, and I say that because it's not integrated, but I can make it that way with the AUX 2 and 300. Okay, so this one does not have 120 coming to the module. To the module on this I have 6 volts. Okay, the 6K is 3 volts. Now everything above that is 6 volts. So this has 6 volts going to it, so I can't drive my lights or anything else. But if I put the auxiliary modules on it, the auxiliary modules work off of 120. So then I can drive my fans and lights, okay? And I'm sure you picture what that looks like in a little bit. That's why I say it's a bastardized thing. It was one of those things that I guess they were coming out with, and then they said, oops, I guess we better make this integrated. And they didn't have 120 going to this, but they did have 120 going to the auxiliary modules. Okay? Yes. 6A? 6A. Yes.
Would the in, the on-off be more like the big six axle situation?
I'm sorry, I didn't hear the last part of that. I heard
in relation to the heating and green module of the truck,
Yeah.
is in on-off and have the
Yeah.
shut off.
Yeah.
The second day shut off would be really weird for residents and things of that nature.
Yes.
And then the on-off would be more like the basic gas.
Yeah, you might find, you still might find them on some direct connects because there's, it's still, I mean, the other thing you're not going to have constant pilot.
So is there a regulation that we should adhere to as far as heating and electrical and some obviously go back to the manufacturers required?
Yeah, I think anymore, I think, quite honestly, I think anymore, this industry is moving away from the dumber modules and going toward the more intelligent modules. So I guess what I'm saying is that I think they're moving away from the GM 6K and the DFC and going over to the IFC. I know there's a lot of companies, a lot of appliance companies that used to use DFCs that no longer use DFCs, they're using IFCs. So I don't know that if I was gonna stock the truck with them, I wouldn't put a whole ton of them on the truck. Yeah, I guess it's dependent upon the area you work in, but I know that most of the new stuff coming out, most of the new stuff is going to integrated modules. So, you're still gonna see these. So it's gonna be, you'll find these probably on entry level. But anything that has any kind of upper quality to it, you're gonna find IFC. I shouldn't say that, integrated modules. IFC indicates it's a SIT. It wouldn't necessarily be a SIT. It could be any manufacturer, just integrated modules, as opposed to the dumber type. So, would I keep them on the truck? Yeah, I'd keep them a couple. But would I keep a large supply on them? Not in my area. Yeah. Yep. Okay, so that is the 8K. Okay, like I said, over there is where I put the auxiliary 200 and 300. They call it AUX 200 and 300. The modulation is the 4 pins to the far left. Okay. Here you can see what I was talking about with regards to the controlling device. Okay, here is my ground wire going with my controlling device. Over here is a fuse link. Okay, so as I come out of the fuse link, I should have a split in the wire, bringing it up here so that things can happen that blows the fuse. So one of these leads goes to the valve, one of them goes up to the controlling device, and that's where the power from the controlling device is received, and then it's sent back on this wire. Over here, I have my green, black, and orange. Interestingly enough, I forgot this, to be honest with you, the ground wire is in the middle. So I have the green wire at the beginning, that's my burner, and then my ground wire, and then the pilot. I think on this one here, I'm just showing you the different things on here. So we already talked about that. Now, the GM8 uses a transformer like this, has a plug-in on it, just like all of SITs. So all the SITs has a system like this on it. On the 8K and 9K and the 10K, it has. No, I'm going to take that back. This is on the 8K. Okay. Okay, that's the battery pack, and here's my fusible link. Okay. This is my GM 9K. This entire row here is 120. Okay. This over here is 6 volts. Okay. So I'm going to use 4 double A's for this part here. This part here is going to be driving my fans, lights, combustion fans, etc. Okay. I absolutely cannot tell you what all the switches are on this, and I have to look at the diagram on this, and I'll show you this. It is so screwed up. For me, it's just, you have to follow the lower wires going back to the module. Where they go on a module, it makes no sense to me. Okay. Over here is my connection for flame modulation. I guess that's everything. Okay, this is still the 9K. This is where my 120 comes in. Okay, so I said this side, this entire side is 120, and it is. So here's where my connection goes. These two here, I can use it for either lights or fan. Same with that. Okay, I'm waiting for the slide that shows you that one, to be honest with you. Okay, there it is. Okay, I know this is blurry, and I apologize for that, but on this one here, my ground wire, I have, first of all, I have one blank terminal. So the second terminal in is my ground. The third terminal in is my burner pilot. Fourth one in is blank again. So number 1 and number 4 are blank. Okay? So those two terminals do nothing. Then I have my burner. Then I have my battery pack, my black and red for my battery pack. I have my transformer and a ground. Okay? And quite honestly, I forget what that one goes. Over here is my, can't move that, I don't think. Over here is my flame modulation. So this one here has 2 blank terminals on it, and the ground wire is kind of plays funky. There's even ground wire over here in the middle of the signal coming from the signal that comes from the controlling device. Okay. So there's 3 wires going to the controlling device, including a ground. Now that over there, I talked about all those things again before. Okay, now this one here, this here is the GM. Sorry, this is the 6003-3V. Okay, does this sound at all familiar? Guess what, guys? This one here, these terminals are TH, TP, THTP. That is what's embossed on that red controller. Okay? And on the THTP, instead of stealing electricity to hold the magnet open, it sends the signal over to activate power. So this wire here is going to send a signal to my pilot to energize the magnet to open the valve. Okay? These two here are for my, one of them is pilot, one of them is the neutral. Okay? So this is a little bit funky again. I don't particularly like this out because of the way it's set up, but yeah, I mean, it's workable. Okay? This is the 6003V. Okay? Now this is the one I told you a little bit ago, has the yellow wire instead of the orange wire. So if I remember correctly, it's black, yellow, black, green. I might be wrong on that, but I think it is. Both of them have a ground wire going to it, as opposed to one ground wire going to the valve itself. This has 2. One for the pilot, one for the burner. Okay? And there's only 4 pins. Okay? This is my valve here. This one here is my H3V. Okay, my H3V looks more like the SIT. Okay, this one here obviously has the motorized section setting on it, so this would be the MH3V. Okay, there are 3 different iterations of this. If I took this off and put a manual on it, it would be HVVK. If I took that off altogether and had no modulation, it would be H3V. Okay, so I have 3 different types of valves on H3V with 3 different controlling devices for the flame modulation. There is no separate controller other than the wires for my flame modulation. What you're looking at there, that orange one, is the EV1. That's going to be the pilot. Okay, the EV2 is over behind the stepper motor. You can't see it. I'll give you another picture. Yeah, you can see it. There are my ports for pressure. Okay, this is looking down on top of the HVVK. Or HVVK, because it has a manual adjustment on it. So my EV1 is over there with the circle around. My EV2 is over here. So my pilot is over there, and my burner is kind of tucked in alongside of my modulation. Okay. On the 6003 valve, the two terminals on the right are for the pilot, two on the left are for burner. And like I said, most times that is not orange. It'll be yellow black instead of orange black. Okay. Those two are for my burner, and that's green and black. Okay. Okay, so now the auxiliary modules, the 200 and 300, are their attempt, Dexton's attempt, to integrate a non-integrated module. Okay, so this is the one that I should say plugs over on the right-hand side. And what they do is they have their own power source. So they're all, every one of them, both the 200, 300, is going to have 120 going to it and 120 going out of it. Okay, then that is controlled by the module, the 6-volt module. Okay, so therefore, like I said, blowers, lights, and power vents. Okay, so this one here is a AUX 200. Okay, the pictures that I took here aren't very good, but in here there's only, this is all black, it's hard to see, but there's a one device in there that you plug into. This is over to your lights. This is your 120 supply coming in. Okay, so this is the 200. You can only control one thing with it, and you have to choose what that one thing is. Okay, lights or whatever. Okay, this is the 300 module. This one here, you might be able to see here, I have two places where I can plug things in, so I can control two different things. This is, again, going over to my module. This is my 120 coming in. This is going to be devices here for controlling my lights or a fan or combustion. And I have two of them here, so I can make my choice on two of them. Okay, it can be either lights and fan, or it can be lights and combustion fan, or whatever you want to make it. Okay, so this one has 2 ports on it. The 200 only has 1 port on it. Okay.
So, quick question. Well, that's a 120 volt model. It does not have an interior internal transformer with it.
No,
That's
that's 120.
Both
Both in and out. Yeah, both in and out is 120. Okay, now let's look at the SIP ProFlame and the ProFlame 2. This is the battery pack for both of them. Okay, it can be either one of those little square ones like that, or it can be a flat. This one takes 4 AA batteries. Okay, the same as what the 9K does. Okay, and an 8K. 8 and 9K takes 6 volts. Okay, so the battery pack looks like that on these. And on this one here, this is the transformer for the SIP. And I wanted to blow this up because this here is on all of your transformers. So if you don't know what's going on with it, you can look at the side of this or the base plate. It's usually either here or here. Okay, on our SIP, so you put it on this extension right here, and you can see the input on this is 120 volts of alternating current, and the megahertz, that's the cycle on it, is 50 to 60 cycles with 90 milliamps. The output on this critter is going to be 7 volts of DC current. So now when I'm testing on the opposite side of this transformer, everything is going to be 7 volts. Okay, and it's going to be 7 volts of DC current, not AC current. Okay, and you need to know that, because otherwise you could be kind of screwed up. Okay, so those two lines there you need to be aware of. Okay, and like I said, they're on all of them. So regardless of the transformer, that could be stamped on it someplace so you can see what's going on, okay? I'll talk about that later. This is my DFC, or my digital fireplace control. This was SIT's first attempt at flame identification. Now, all of these things they designate as CNs. So this is CN1, CN2, CN3, and CN4. I don't know if you need to know that or not. I never use that, okay? This is where my main Molex connector plugs into my valve, into my control, okay? This one here is my ground, this one here is my spark igniter, and up here is my sensing rod, okay? Now, while this is on the board, and while I'm thinking of it when I bring this up, on early iterations of this valve, this module, they put, and it's still there, they have a ground ring sitting along the right side of the spark igniter, okay? The earlier iterations of that from the factory, they did not have the ground female insulated enough, so it was sparking between these two terminals. Consequently, it wasn't sparking in the spark igniter. Okay, so be aware if you come across this. In fact, I'm going to even say, be aware that if it's not sparking in the sparking rod, make sure that female is pushed down onto the male so that it's not jumping between these two terminals. Okay, so that's still a problem. They still do the same thing with that. So just be aware. Okay, so that's my ground and spark igniter. Now I'll go over here and talk about my Molex connector coming in here. SIT does something a little bit different with the DFC control. These first three terminals here are power. Okay, and I forget which one is which. I think the black wire is number 3. Number 1 wire is battery pack. Number 2 wire is voltage from the wall. I think that's how it is. We'll look at it here in a minute. They have 3 wires for the controlling device. White, blue, and green. Okay, and then they have 3 for the valve. The burner, pilot burner, and ground. Okay. So that's how the module is set up. The 3 wires for the command, or for the controlling device, they give you an extra wire so that if you want to wire a second controlling device in, it's pretty simple. All you got to do is tie it into the remaining wire that's not going out. So consequently, guys, on my props, as many times as they have been handled by everybody, you're going to have to look at and see what goes for controlling, because people might have moved wires around in different classes. Okay. All I want to be aware of is if the power is getting back to my module. Okay. So you might have to, if you suspect that there's a cold control problem, you might have to test all 3 of white, blue, and green. Okay. Because I don't guarantee how they are wired now. Okay. This is my 880 Pro Flame valve. Okay. The 880 valves, all of SIT's valves are based off of this one here. So there's only one valve, where a deck has 3 valves and 4 modules. We have 1 valve and 2 modules with SIT. Okay, so my pressure taps are right there in line with where they always are. My EV1 is right here, that's my pilot. My EV2, which is my burner, is right over here. What you can't see on this picture is the ground, okay? The regulator, that's my pilot adjustment regulator, is that thing that sticks up there. So again, so here's my 880 again, side view of it, and everything there is what we just looked at. Okay, this is the 885. 885 has remote modulation. Okay, so on this one here, I have a stepper motor on the far right hand side that takes the place of my no modulation at all. Okay, it is the exact same valve, except now they've taken that one piece off and put the flame modulation on it. Everything else is exactly the same. All of the operating numbers are exactly the same. So I got my EV1, EV2, my flame modulation. Okay, this one here is the 886. Exact same valve, except this one is manual flame modulation. So you got 880, 885, 886. Okay, the 880 is no modulation, 885 is stepper motor, remote modulation, and this one here is manual modulation. Okay, again, they look exactly the same except for whatever the device is above the regulator. This is my IFC control, integrated fireplace control. This one here, by the way, the other one was DFC, digital fireplace control. This is IFC, integrated fireplace control. The entire top of that is 120. So everything on the top is 120. Everything on the bottom is 6 volts. Okay, so this here, let me go talk about this a little bit. This one here is my fuse. This is my power coming up to the module. This is my fuse for the module. These two are for fans, these two are for lights, these two over here are for combustion fans. Okay. Down here, you can barely see it, there's a little red button. That little red button is what I push to reprogram my remote control. Okay. Moving across here, this is for my that's your application, any other application you might want. These 4 here, 5 here, are going up to my stepper motor. This connector here is going to be my main motor connector. This is going to have, these 4 here are going to be for my valve. This another one is for other apps, and these 3 over here are going to be for power. Okay. This one here is my switch. Typically, if you're going to order a fireplace and it's going to have the IFC control on it, you're going to get the remote control with it. This is not going to have anything but a jumper wire there. So it'll be a jumper wire from one terminal to the other. If you want to add another controlling device, you replace that with wires going to your controlling device back from your controlling device. Okay, here's my spark, my sensor, my spark igniter, and I guess that's it. Okay, the Maxwell GV60. This is their receiver. Okay, this is not a module. You can see the battery pack is inside the receiver. Even people that handle this agree that the support is on. Because the battery pack on top of it, if the battery leaks, it drops down into the electronics and ruins the electronics. Okay, so just be aware of the battery pack there. And remember, this works off of AC or DC backup. So it's all the time is using AC power on it. So it's a good thing to tell the customer not to put the batteries in there until power goes out. Because like I said, if they're in there too long and they start leaking, it ruins the receiver. Right here on the very front, you can see that little hole there. That is for resetting the receiver with your remote control. This device right here is my antenna for receiving signal from my remote. Over here is going to be my spark igniter, my module, my Molex connector comes in here on the right-hand side. Up here they have 2 different switches. One of them they call is for the thermocouple, the other one is switch, I think is what they designate it, if I remember correctly. Okay. So this one here, I'm going to go over this a little bit, because like I said, it's a bit different than anything we looked at so far. My thermocouple is going to come into the one on the screw on the right-hand side. But it's not going to come directly from the thermocouple. It's going to take a trip from the thermocouple to an interrupter block, through the interrupter block over to that screw. Okay. Now, the next part of the circuit, there is a solenoid inside of the receiver there that is going to send the signal over to the switch connector. The switch connector goes back then to the interrupter block, which is attached to the valve. And when it gets the signal back to the interrupter block from the switch, then it turns the appliance on. You can see over the bottom, these here pins can be used, and not always used. This can be used for my external power, and this is my module that goes over to my valve. Okay. This is my valve. Over on the far right is my on-off lever. Okay, right immediately behind it, or underneath it, I should say, not behind it. Immediately underneath it is my servo motor. Okay, this one here is not a stepper motor. This one has an infinite number of settings between high and low. Okay, so I can adjust the flame any different size that I want it. Okay, the Molex connector connects right there from the receiver over to that module, my harness block. Okay, over to the far left is my controller for my valve. Right now it's set in on automatic. I can write this manually. My other modules that we were looking at, we could not write manually. So this one here, if I take that arrow and I point it to manual, then I take a screwdriver and drive down through the larger of those two holes. I'll get down here and I'll fill a little lever, push down on the lever, that allows gas to go to the pilot. Like my thermocouple, like my pilot, while the thermocouple is being heated, I hold that down just like I did on a millivolt. When I think that it is reset, I can release that. Then the current is flowing from that thermocouple over to my interrupter block and over to my red wire on my receiver. Okay. At that point, it is not going to the yellow wire back over to the valve at that point. Okay. So now I have it set on manual. What you can't see on this picture is the on-off on it. All the valves will have an on-off on it, and you can't see it on this picture. Okay, but now within the manual position, make sure that the switch is in the on position. I can operate it manually. I can turn that knob and actually manually manipulate the knob over on the right-hand side. When you do that, there's an ungodly sound that comes out of that, and it just sounds like the thing is just being torn apart. But my Max controller that I have back here, without exaggeration, I bet you that thing has been turned a minimum 500 times. And it still goes when you're turning it, and it works with the remote control every time. So whatever they're using for gears in there is pretty hard. Okay. So that's the valve. That's the burner servo motor. Motor connections is on the right-hand side. I didn't mention that. The other one coming in from the valve is right there, and like I said. And then the knob is for my manual operation. By the way, if I want to work the appliance remotely, and I have that set on manual, it won't work. Okay, I have to move that over to automatic in order for the appliance to work with the remote control. Okay. Pressure taps on this are at the most inconvenient place that you ever want to see. They are a righteous pain in the butt to get at. They are located right alongside of the inlet gas. Okay, so super difficult to get to, super difficult to work with. That's the German revenge on us from World War II, I think. Okay, on this one here, you kind of get an idea what's going on. Here's my thermocouple. My thermocouple is coming over here. Sending my current from the thermocouple when the pilot's on over from my interrupter block. The front part of my interrupter block is going to send that signal from the interrupter block over to my thermocouple, which is the red terminal on this, okay? Goes through the solenoid in here, comes out the switch side, comes over here and goes over to the back side of my interrupter block. I know you can't see it. Let me see if I can. Not a very good picture, but that black line right there is the insulator that insulates the front wire from the back wire. Okay, so there is a black device in there that separates. It's plastic. Okay, so when it gets back over here, it's that valve. The valve's looking for a minimum of 5 volts of electricity, which then turns on the burner. Okay, I have some videos on that, so you'll see some videos on how that works. I think that's showing the exact same thing as we just talked about. Okay, now I'm not going to do what we did yesterday with the electronic ignition. Now what I'm going to do is I'm going to talk our way through these things, okay? Because there's so many variations of it. The first thing I want to talk about is power going to the valve, okay, from the wall. Now, again, I'm telling you how I would do it. I would rarely check the voltage out of the wall. If I'm looking for voltage, I'll check the voltage at the module. If I don't have it at the module, then I'll go to the wall. But I start at the module itself. But again, the way you work these things is your procedure, okay? I throw this caution again. It's going to be 120 going to the module in all cases. On the dumber modules, we don't have to worry about any 120 any other place except where it comes in. After that, in fact, it's not even 120 coming in. It's either 7, 6, or 3. Okay. So be aware that you do have 120 up to the transformer anyhow. Okay, like checking line voltage at the module. Like I said, this is my first test. If you want to check it at the wall, hey, that's your procedure. So I start at the module, and they're all, we do them all the same. I mean, when you're checking for power, you're checking for power. Okay. So on the one on the far left there, I have my transformer. Then I have the plug-in type of transformer in it, so that's where it plugs into the module. Okay, so on the Maxi Control, like I said earlier, I have that auxiliary power block. It's not all the time, it's not always used. Some of the times it's brought in underneath and you don't even see it. Okay, so anyhow, that's where the power comes in on those two. Dexin is the same type as SIT, so that it'll plug in is someplace on the module. Okay. Okay, so I already talked about the side of that. So you want to verify what that is so that you know what you're going to be testing with, what your voltage is you're going to be testing with. Now, to test the voltage coming to the module with this here, you're going to put your one probe inside of the plug-in, and the second one you're going to put on the outside. Okay, I know this is a SIT that I'm testing here because I have 7 volts. Okay, they have 7 volts on theirs, Dexin has 6. So that particular transformer that I'm looking at there, the one I'm testing, is the SIT control. You'll notice that I have my multimeter set on 7 volts, I have it set on 20 volts of DC current. Okay, if that was a Dexin, I would have it over on the 200 of the alternating current. Okay. Okay, now I'm going to follow the line harness. What I'm doing here is checking line voltage still checking line voltage at the module. I'm going to follow the wiring to the harness on the module. On the SIT, DSC control, lead number 2 and 3 is where I've been testing it. Okay, so I'll show you that here in just a moment. And remember, we're talking about red bikes. Okay. Okay, so I'm gonna go on the module, this is my DFC. I'm going to be touching my second terminal. This is coming from my transformer. Okay, so this is plugging into my module. It's going over to my Molex connector. I have the second wire is going to be my power coming in from the transformer, and my black wire is going to be my neutral. So I'm going to be touching those two wires, and I get my 7 volts. Okay, so that's my AC power coming in. Remember that number 1 wire. Okay, now on the ProFrame 2, I have my power coming in up in the upper left-hand corner of the module. It is really hard to sneak in behind that thing and get any readings with your multimeter with this connected. So you might have to pull that off to test it. If you do that, make sure you don't get zapped. I did that already, taking these 2 terminals off here. Sometimes if you're careless, you can touch around and get a little bit of a zing. So here you can see I'm touching the 2 wires. That's the 2 wires here that I just removed. Okay, and it's showing 119 volts. Okay, on my GM6K, my incoming power is the very bottom of the module. So those 2 terminals at the bottom of the module. This one here, you can't sneak behind it. You don't have to take the wires off. You don't have to test that portion. You can just raise these a little bit, put your multimeter in behind that, and you can take a reading on the module without taking the leads loose from the module. On my 8K, my plug-in is here on the left-hand side. I can pull that out and test that like I showed you before, okay? Because it does not come down here. Internally, it comes down there, okay? So I'm only going to be testing that probe, okay? That's the only thing I might test on that. This is my 9K. My power is right here. Again, I can't sneak in behind it because you can see that there's a plastic shield on the front of it, and I can't get to the other side. So I have to remove it completely from the module and test it in the adapter that's coming up to that. Okay. Now check the battery voltage. Okay, on the Maxi-12 controller, this is a 5 pin that we talked about earlier. Okay. You may or may not have that there. So if that module is connected there, if there's a Molex connector there, you might want to take that off. In fact, you're going to have to take that off. Then you're going to go in and you're taking the very last pin over here, last pin to the left. Okay, you're going to touch one of your probes to that, second probe to ground, and that's your voltage coming from the battery pack. And for Maxi-12, I need a minimum of 5.8 volts of VDC current coming from my battery pack in order for my system to work. Okay, that's my minimum. If myself, I put this on. All my slides, guys, are from the manufacturers. All the numbers are from the manufacturers. Okay, they said I need a minimum of 5.8. I added this little one at the bottom. Okay, I like it to be 6 volts. If it's 5.8, it's on weed. If I walk away from it and it stops working, trust me, I call you back because I didn't change the batteries. To me, that's dumb. Okay, so if it's less than 6, I like to change it. Okay. Pardon?
At least my company, you change the battery.
Yeah.
We would need it.
Yeah, it's good policy. On these here, I'm going to test the 2 terminals at the battery pack, and that gives me the voltage coming out of the battery pack. So both of those actually have those attachment type things. Looks like a 9-volt battery attachment. Okay, that's what I'm doing right there. And out of the battery pack, I'm getting 6.17 volts. Now I'm going to go over to the module, and I'm going to try on the module. Now I'm going to go into that number 1 wire, and I'm going to go into my black wire. So I'm going to be sliding my probe down alongside number 1 and the second probe on the black one. So it's going to be 1 and 3. For this one here, for the, coming out of the wall, it was 2 and 3, okay? So, gonna be tested there, and you can see I got 6.1 volt volts. I'm good to go. Okay, on my IFC control, it's pretty easy on this too. It's the 2 last terminals on my Molex connector. And it's red and black wires. Put my probes in there, and I should be getting at least 6 volts of power. Okay? On my GM6K module, the bottom 2 pins are for my battery pack. It's kind of hard to get behind them. You can. It's a little difficult in sliding them up on the post because it's a module itself. So you're probably going to have to go down from the top to test them. Okay, and the bottom 2 are battery pack. I need between 2.6 and 3.3 volts of direct current. Okay, this is my 8K. Oops. It's these 2 terminals here. I had to stop and think what it was. First 3 are my valve. Next one is my controlling device, and these 2 are my battery pack. So it's the last 2 pins. And on the 9K, it's the 4th and 5th posts on my Molex connector. Okay, that's the one that I showed you. It's called kind of wonky. Okay, where number 1 is blank. Okay, so we're going to be looking to get 120 over to the appliances. We're going to set my multimeter to read 120 from that point. Okay, this is checking it at the wall. So this is the last thing that I need if I don't have power to my module. Okay, so I'm going to be setting my battery, my multimeter to read 120. My black lead goes into the common port, and red lead goes into the V port. Okay. Insert your leads into the receptacle, and you should be reading 110 or higher. So I have my multimeter set for alternating current, and it's setting on 200. So plug it into the wall, you can see I get 123 on that reading. Okay. So there's a schematic for the same thing. Okay, if I have no power at the wall, there is only going to be a couple of things that I am going to do. I'm going to make sure that the receptacle is not switched, number 1, and the second thing is I'm going to make sure that the circuit breaker is not thrown. Anything other than that is a reference to the electrician. I am not going to pull the faceplate off of the box to make sure that the box is wired. If it's not wired, I can't do anything about it anyhow. So I'm not going to waste time doing that. So check to make sure circuit breaker is on. Number 2, I'm not going to do that. Number 3, I can do that. And number 4, it's called an electrician. Guys, because we started early, might as well go to 9:30. Or do you need to break earlier than that? We were breaking an hour, 15 minutes before, so maybe an hour and a half today. Is that okay? Okay.
Yeah.
So we already talked about where they came in, so this is just telling you to make sure that the wiring harness, the Molex connector, is pushed down on the pins. Okay? If you take the Molex connector off, be really careful when you put the thing back on that you do not bend any of those pins putting the thing back on. Okay, now what I want to do is I want to start through problems. Okay? And again, for the very first one, I will probably do all of the valves and modules the same. Okay, so I have no spark at the pilot hood. Now, number one, I'm gonna make sure that the appliance is not locked out. If it is locked out, I'm gonna follow the procedure for that particular module to take it out of the lockout position. Like I said, Dixon's IFC, they say it only has to be 2 seconds. I've never been lucky enough to see that, okay? So if you take it out of the lockout position and it still does not spark, then you want to follow the following procedures. Make sure that the appliance is in the demand position and that it's calling for heat. Okay, so I want to check my continuity through my wiring loop to my controlling device. So whatever the controlling device is, I'm going to check my continuity through that wire. Remember, one leg has to be broken down. Just remember that, okay? Because if you try to test it from the module and you don't have one leg open, you're going to get false leads. You can test it from the module. You can do that, just making sure that one leg is disconnected or open. Okay. Okay, like I said earlier, for the DFC, the colors for my controlling device are white, green, and blue. Okay. And I've had to find a wire that's wired and then check for continuity. Okay. If I am going through a auxiliary on-off switch or a CPI switch, I need to measure my continuity through those switches. So not only to them, but through them. Okay. So be aware of that. The third thing I'm going to do is I'm going to make sure that my ground is good. So I'm going to check my ground plane from module to ground. Okay. So the yellow wire is my ground wire on this module. On the Dexon over there, the ground wire is the black wire, the first black wire. So I'm going to check that to ground. Okay. Because I want to make sure that I have a ground going back to my module. If I don't have ground, make sure that wherever it's grounded to, make sure that that connection is nice and clean. I do not like to see it because it's a ground wire. It can take just a little bit of resistance to interrupt the ground signal getting back to the module. So I like to see bare metal. Okay, so if it's grounded to a painted surface, I don't know, some of you saw me with that little wire brush I had the other day. I will scrape the paint off of the wherever the ground is attached. Scrape the paint off of it with that and then reattach it to the bare metal. Okay. I also check to make sure that there's no corrosion taking place. So I still don't have any spark to the module. I'm going to verify the gap is around 1/8 of an inch. I'm going to make sure that I don't have any debris on my pilot hood or my spark igniter. Okay, so I'm making sure both of those are clean, and going to check like I did with the millivolt systems. I'm going to check to make sure that my igniter does not have any cracks or chips in the porcelain insulator. And then the last, I guess, check for continuity on the wire, make sure that the wire is good. So that would be from the disconnected wire at the module to the tip of the spark igniter. Okay. If I don't have continuity there, I changed the whole pilot assembly. If you want to change just the spark igniter, that's your choice. Okay. Very last thing I'm going to do after I've checked all those other things, I'm going to leave that wire off of my spark igniter post. I'm going to take a jumper wire, I'm going to attach a jumper wire to that male probe that's coming up. And I'm going to take the other end of that wire, I'm going to put it with an 1/8 inch of ground, and I was going to see if it sparks. If it sparks, my module's good. If it doesn't spark, my module's bad. Okay, if it's sparks and I'm not getting sparks up the top of my spark igniter, the pilot assembly is changed. Okay, you don't want to do what I did on this picture. You don't want to grab a hold of that metal jumper, but you know you can do it with gloves on or with insulator on the top of the alligator. Okay. So like I said, if it sparks, module's good, doesn't spark, the module's bad. I can do that with all of my controls. So that's why I kind of balled these all together. So I don't care if it's Sexton, SIT, or Maxitrol. I can test it all the same way. Okay. Make sure, this is my VFC, make sure that there's no spark jumping between my CN3 and CN4 terminals, like I talked about before. Let me just tell you, I've taken off one of those wires, typically the ground wire, taking the ground wire off to check for ground to my ground plane. And when I put it back on, I didn't slide it on the whole way, so it wasn't all the way down, and guess what? I had the spark taking place there. It's my fault because I didn't make sure that the female was pushed down onto the male on the ground wire. So make sure that it's all the way down on that. If you have that there, it's simple to fix. All you need is a piece of black electrical tape and wrap it around the terminal. So it's not a big deal. Okay, now the pilot and light. Now I'm going to start going into each individual modules because now things kind of changed a little bit. So my problem is in my pilot and light. So we'll start off with the SIT Pro Flame. Okay, this is the first thing that I'm going to do. I'm going to take my EV1 wire off of my terminal at the valve. Okay, this is my orange wire. I'm going to pull my orange wire off the terminal, and you have to be, guys and ladies, you have to be really gentle about doing that. That probe for the EV1 and EV2 on all of the valves is very, very small. Small in width and small in thickness. So you have to be careful when you're pulling that off, you don't break that pin. Okay? So be gentle when you take that thing off of any of the modules. Okay? So I'm going to remove that from the valve. I'm going to take my multimeter and set it on to continuity, auto continuity, and I'm going to test it from the disconnected wire, back to the module. I don't want to see anybody put a disconnected wire in there. That's not doing anything. I'm checking the continuity of the wire. I want to know if there's electrons flowing through that wire. So the disconnected end to that, back to the module. If I have continuity on it, the next thing I'm going to do, I'm not going to reattach it yet. The next thing I'm going to do is I'm going to check my ohms reading through my valve. Because I have to have that wire removed in order to do my ohms check. So I'm going to keep that wire removed from my valve, and I'm going to set my meter to read ohms, and I'm going to put one lead on the terminal that the wire goes on, and the other lead I'm going to go to ground. And if the ohms reading jumps around a lot, just take your one probe from your multimeter and scrape the valve so it gets nice and shiny underneath there, so you get a good ground. Okay, so I'm going to check that on the SIT control. It's going to be somewhere between 340 ohms plus or minus 20 ohms. Okay, and that will be on that cheat sheet I handed out to you. Okay, so if I have no continuity, obviously, or if I have ohms already reading outside of that, it's too hot and needs to be changed. Okay, so this is where I'm going. You can see that black line over there for ground is going to the valve wire. Orange wire is being touched, the terminal there is being touched with my other lead. And when I do that, like I said, I should have somewhere between 320 and 360 ohms of resistance. So now what I'm going to do, now that I know my valve is good, now next thing I'm gonna do is I'm gonna put my orange wire back onto my terminal. But I'm not gonna slide it on the entire way. I'm only gonna put it on a little of the way because I need a little bit of space behind that where I can sneak in with my probe from my multimeter. So now I'm gonna go in there and touch that, and I'm gonna come over and ground the other probe. Now I'm going to put it in the demand position again. Now when this tries to light, okay, I'm going to get on the DFC control, I'm going to get between 4 and 6 volts of energy there, DC energy, to energize my valve, okay? So that motor, think of it this way, this is the same type of magnet as we talked about yesterday when we were pushing down on the knob. Now, instead of that little bit of power, now I'm going to use increased energy so that it does it without us holding anything down. Okay, so now my voltage is going to be between 4 and 6 volts of DC current. If I have that, it'll pull that magnet open, and once it pulls the magnet open, then I have to have current there to hold it, but I don't need 4 to 6 volts. So now my energy is going to drop from 4 to 6 volts down approximately 0.5 volts. Okay, so those are my readings on that. 4 to 6 for the peak voltage or the energizer voltage, whatever you want to call it, and for the whole voltage, I need 0.5 volts of DC current. If I don't have power there, my module's bad. If I have power there and my pilot's not opening, the valve's bad. So, pretty simple test.
Repeat that one more time, if you have power there in the.
If I don't have power, the module's bad. If I do have power,
Valve.
valve's bad. Yes, sir. Yes, sir. Yes, ma'am. Yes, you do. I was thinking this morning, I don't see Richard here. I only have one flash drive with me. Maybe tonight I'll go over to Walmart's and pick up some flash drives. So instead of you waiting for me to get my computer fixed to get these slides, if it's okay with Richard, what I'll do is I'll just copy them off of my computer and hand you a flash drive. So we have 4 companies, is that right, or 5? We have 5, because, but I wouldn't be back in time for that. Bart might have to wait till I get my computer fixed, because I won't go over to Walmart's until after class today. Oh, you also? Okay. Anyone that is leaving tonight after class, please give me a business card with your email address on it, and I will make sure that you get this. But please understand, my computer guy's gonna have to work on it again to find out what the heck's going on with the Google Drive, because it's not working. So, if you give me a business card, it is not gonna be, obviously it's not gonna be this week. And I wouldn't expect it until maybe Tuesday next week, if at the earliest. So, anybody else sticking around, I'll be happy to get a flash drive and make a flash drive so you can go home with it. Okay? And this starts all the way back at the slides for annual service procedure. So annual service procedure forward, you're going to get, it's kind of, like I said, I think it's 350 slides. So it's a bunch of slides. And once they're in your possession, they're yours. Okay? What you do with them is your business. I don't care. If you don't like them, you throw them away, tell me so I don't put them on flash drive. Okay? But you can manipulate them any way you want. Delete slides any way you want. Like I said, I don't care. It's your property at that point. Okay? So now I'm moving over to the the IFC, I think. how come I have those numbers there? Okay. So anyhow, this is, I'm testing my, on this one here, you can see I'm testing my orange, the top one, I'm testing my voltage at my orange terminal. That's my peak voltage, or energizing voltage, whatever you want to call it. So I'm reading 4.29. I'm telling you right now, you have got to pay close attention to see that number. Because as soon as that picks, it immediately drops down. So my peak voltage is 4.29, and it's dropping down to 0.94. Okay, and that's the way it's supposed to. It has to be greater than 0.5, it has to be between 4 and 6 volts. Okay, this is 4.29, that's good, and it's 0.94, which is above 5, which is good. Okay, when we get around talking to Dexon, you might get some really high readings for Dexon. It's okay, okay, as long as it's over the minimum number. Okay, so that's my DFC control. Then I'm going to go back and do all this stuff that's in yellow is all of the stuff that we did on the milliroot system. Okay, I'm going to check pressure, I'm going to make sure gas is flowing, make sure the orifice is clean, verify the gap between the igniter and the pilot. So all of that stuff is what we've already done with millivolts. So I'm going to have to do the same thing with electronic ignition, but in addition to that, I have an electrical component. I personally like to check my electrical component first, and then I go to this. Okay, and that's just showing you where you're going to test all those things. So this is still DFC control. The pilot's light, but the electrode keeps sparking. Okay, so now I have the pilot flame, but my electrode keeps going tick, 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 tick. Okay. Okay, make sure the flame is fully engulfed in the sensor. If not, then just adjust it so that it is. Verify that your sensing wire is connected to the DFC module. Okay, make sure the DFC is grounded. Remember how you do that? You do the ground plane check on that. You put one wire on your chassis and the other wire on your module. Okay. Ensure that the flame sensor and the pilot are clean. Confirm the flame sensor has continuity. So I'm going to take the wire off of the module for the flame sensor. I'm going to take the disconnected wire, I'm going to touch it there, and I'm going to touch it up at the end of the sensor. If I have continuity there, it shows that my module is bad. If I don't have continuity there, then the wire is bad. So then I have pictures of engulfing the flame, where you're going to touch it, and blah, blah, blah. So all those things. So now I have gas to the pilot. My pilot's lit. My electrode stops sparking. Now I have no gas to the burner. Okay. So I want to check the batteries on my sender and receiver. Make sure my receiver is set to remote. Check transmitter. Make sure it is turned on. Ensure the receiver and the sender are synchronized. This is on the DFC. Verify the thermostat is in the demand position. Make sure the pilot is positioned to provide ignition. Verify the burner orifice is clean. Okay, now I'm going to go down, and again, I have this out of sequence. I really need to change this one. Here, now I'm going to go back to the procedure, the exact procedure that I used for my EV1. I'm going to go over to my EV2, which is my green wire. I'm going to pull it off of the valve. I'm just going to check continuity between the disconnected wire and my module. If I have continuity through it, my wiring harness is good. If I don't have continuity to it, my wiring harness is bad. Okay, I cannot replace that just out of one wire. I have to replace the harness. Okay, so now again, before I put the thing back onto the valve, I'm going to check for ohms of resistance. Where's my ohms of resistance? Where the heck's my ohms? Here, wow, that's really out of sequence. Wow. I definitely have to fix that. I have to make a note on that. Okay, so this is my first thing is I'm going to be checking the continuity of the wire. The second thing is I'm going to be checking my ohms resistance. And the nice thing about the DFC is all the numbers are the same. So on ohms resistance, 340 plus or minus 20. So the same thing is what I had on my pilot. Gotta go back and find where I picked up here. Okay, now when I reattach the wire, I check my ohms resistance, and that's good. So my valve indicates that it's good. I'm going to take my green wire, slide it partially onto my terminal, slide my probe from a multimeter in behind it, and I'm going to check my voltage coming over there. Again, I need between 4 and 6 volts of current. Okay, this set for 2 seconds. I promise you, you're not going to see that voltage there for 2 seconds. Okay, it's going to be bam, and that's going to be the end. Okay. After that energizes or picks the magnet, then it drops down to 0.5 or greater. Okay. Okay, I got 9:30. Why don't we take a 15-minute break, and we'll come back.
A lot more linear.
Pardon?
This is a lot more linear.
Yes. That's why I think it's easy.
Still a lot more natural.
Pardon?
Still a lot more natural.
There is, but like you said, it's just,
Going down one.
yes. And for me, it's just kind of intuitive. The only thing I need to know is the numbers.
Right. And then the honey butter, done deal anxious.
Oh, boy.
Oh.
It's fine. I'll be looking. I gotta read my head and talk about that, all this guy. Honestly, I don't know. I've got the. I should call it again. Yeah. Oh, I put them dry. That's all they can have. One more couple days. Yeah. And go. Yeah.
I never do this.
That's what's supposed to be good at it. This guy take like never nothing. Yeah. Remember. Oh yeah, that's what the. I think my wife was supposed to get at the top. Worry about running. Yeah. I I'm glad I didn't. We have them. I don't see where I get one to you know, so they are. So it's time to do it. Let's do it. You gotta use their one of these. I'm trying to do the plan. I saw the question. And then I screamed about the question again. I prepared on two lanes. Car. Now, I never got all this. They're all over the yeah, that's my dog had one, so I think it's yeah, they watch. I was reminded they. Oh, it's not go back. Yeah. You know, we're getting put it backwards. Yes, it is play with it. If you're on the side of my thing. All the way. Yeah. Oh, no. Yeah. I'm not like the first like their things over. Yeah, it's right. Oh, yeah. Kind of we need to mediums. I'm throwing sound out of that. Kind of later garbage. But it's a little bit particularly to oh, yes. And like maybe like it does that too. Yeah, because that way it's not any of snow. I love you as others, and I'm like, you know, it's way out of order. You should see that. And I'm stuff with that's not so it's the opposite. Yeah, you know, not that you can I'm going to be like a good picking up miles and then kind of like. I am what they're saying. Why not side of the songs? Learning you, but right now, you got Wi-Fi. They stay on it. You know, Wi-Fi. You don't have Wi-Fi. It was like right. Well, I did start reading Wi-Fi. Started by saying like that. You have Wi-Fi. You have Wi-Fi. But also, that's it's like it's storing an image based on in the house. In a file, yeah. Always everything. It's all every officer, so it's all bouncing off and picking up like the movement. It's like you're losing.
If you understand this question, obviously you're not going to be saying everything. But if you understand the question, oh yeah. I get wondering why you know it's that people talk about it. And I get wondering why it is. What is happening? I don't focus this on my love. Yeah.
Good matter, what for, absolutely. Yeah.
no.
Yeah.
Last one.
Oh, I'm
I
just.
don't think so.
Yeah, sure.
Yeah, but that is awful. You can call them awful. They're like, all right.
Okay. And I can't figure you're not that expensive. I don't like.
You know that PDF one?
They're kind of expensive. I don't want to throw them away.
That's what we're playing.
Too many of them.
Okay. It's pretty much here.
EFC, that was not.
Really? They had this time that you gotta look at different answers. So it's your whole day. From here, all the way. It's like this will make sense though.
Trainer coming with that? You're gonna go down or down? Some of them will go like, different dog. I don't know, that's a dog. Oh, they got one thing that, got a little bit like some others. You should have knocked down.
Yeah, I'm saying,
I'll tell you.
Oh, now we got like, I'm talking wife for a little while later.
You get turned.
I think it's one stuff, yeah.
Yeah, but that might all belong to it where. No, before that. We get just started on this. It would be a little, because if you turn around and ran, you see where everything's my life. But if you try to step forward on this, everything is going. Well, all right, we had, I know like September, and, no building was. I had. I mean, I think it's 1:30 a little bit. Well, it might be maybe this summer when you go walk around and see.
ah, I see.
Yeah. So the next. My problem is that. A little secret, there's different. Well, building this one. They were gonna look, well, it is a sound. Something I wasn't expecting because I was doing more kind of one with other something when you get to yeah, I know that all in the same thing. You get to like, wait, it's the question. Manual.
Like a little diagram of the control modules and where everything's at, like for each fireplace, or
Normally, yes.
Yeah, I'm more sister morning while leave. I'm like, we should add to Right.
Well, you're gonna get the,
Oh,
but that's not yet ideal. But then my cheat sheet gets busy.
I can work the dogs, the boxers, but the work often, like my general. Dog, pick two, three, I'm gonna go leave, the dog is spectacle, they're gonna fly, it's heel is far enough, and bridge them, instead of the big. Oh, of course, so, cause he's got a lot of space. You gotta really mess yourself up. Yeah.
This one here, all the water ended up in there, so I have to figure out where they all go.
well, nobody better.
Do it. But I might run them away, I think it's for on this 3 months. So maybe it'll take us a house. They're not there.
I'm sure.
Correct. With me, they don't even try. But again, my wife. You still look over. They had no turn. It's a lot. Yeah.
They know, they're like, oh, they said so. Yeah. They like works for it. He worked on this, I think it was a year, he was, Otherwise, like this. One of my kids, my wife. And like most of the of that. Oh, I refer to the other sort of. Very me, don't need it for like, they're like, I mean, when you said it, my dog, that's the whole right time. I don't show this crowd, like, just in it for the ground. Just I haven't. No, say it, you're 85 pounds. Just saying. I'm a struggle. I want that about for a day. So, yeah, it's the only one, the only one, so that's great. I'll have the size. Take one step to the he said, actually, it was no time to get here on the phone, or she could know. My place, you want me to work, start barking, right, I'd be laying in your own. I mean, I'm so proud. What did I ever up to you? Yeah, I'm sure they did, because I was, I just had, they kind of. It might be a thing, right, but I want people to pay them. It's really specific. I could project it off the top, and it's inside, I would have all the rest of it. And we're getting marks, yeah. Not like you should. Right, well, that's they help. And that, yeah, we get friends. So we get answers on. Mass, this. Well, there's too many of us talk that. Okay, but that is what I was okay. Oh, long. Yeah, well, I know that also on Friday, you have some one spot. So I am one of the yeah. Let's see what's good. Yeah. I'm also that. I had a great day. I'm looking for the order line. Which I was,
I had a great day, you know, quite unexpected, it's like that, head over my shoulder, and look, we take a smell of it all. Okay, sit back up a little bit, sit. Okay, that gets me, like, hey, so your guys, yeah, maybe it's a great thing, I have to fly home. All right. All. Yeah, I think about that. Think about it. Check me out. And yeah, it's like going and trying to go on the very front. And it was. It's
Yeah, the one, yeah. Okay, I started putting the props up. I want you guys to take them out. You guys are from here, right? Can you get another table? Either that or vacate Richard from Bell.
We need one more. I got a schedule on here. Just move all that and grab it. Yeah, you're this one, yeah. I just want to see if we're one. I like those. The other one has that well.
I brought up a bunch of electronic ignition.
There's Tiff. Hey. That's a I'm assuming. We're going to swap out this bigger one.
Okay, we're gonna use that table.
There's a bigger
Just
one
put it
here.
right under that light.
I hear.
No, yeah, it's right here. So it's a couple feet away from that. Okay, guys, before I start start talking about the slides, I'm in the process of putting up the props back here. So far, I see two that I didn't mark to determine what they are. I'll try to find my marker pen and do that before you all get there. But anyhow, what you're going to see back here is you're going to see, I think there's only two burner systems. I think there's only two burner module systems that are the same. I think I duplicated the DFC. So I think I have two DFCs. Everything else is going to be independent. So that means when I say independent, it's going to be a module, either a different module or a different valve. Okay. One of my goals, and I don't know if we'll be able to stay here long enough to do this. One of my goals is for you to see every one of the systems. Okay, that's why I work them all along. Okay, so if you work on a DFC, you don't have to work on the other DFC. Okay, so anyhow, like I said, my goal was to let everybody see at least the thing one time. I would like to let them see it 2 or 3 times, but we'll see. Okay, we'll see how quickly things go, and go from there. I hope to get on those things before lunch. So that's my intention. So, all right. You'll also notice there's no tools at the table. The only thing that is there is a multimeter. Okay. For our purposes, we're only going to be checking the electrical part. We're not going to be checking the gas side. So I picked up the manometers, picked up all the screwdrivers, wrenches, blah, 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 blah. Okay? So when you walk back here, you say, where are the rest of the tools? The rest of the tools have been picked up. Because all I'm interested in is teaching you the electronic part. The millivolt part, you already know. So the tools to check the millivolt part are gone. Jumper wires are gone. And the reason I picked up the jumper wires is because every one of the manufacturers says that if you use a jumper wire, you will put the module into lockout. So I don't want to leave that temptation there. So I picked up all the jumper wires. Okay, if you look in every one of the manuals, I don't care which one it is, it'll tell you using the jumper wire to jump something will put the system into lockout. So the only thing you need, I guess you do need a jumper. I'm going to put it back out. You need a jumper wire to test the sensing rod. Spark igniter. So I have to put the jumpers back out. But that's the only thing I want you to use the jumper on is the spark igniter. Anything else, just leave the thing lay there. Okay? Okay, moving in. Any questions at this point on anything? Okay. Moving on, remember, you all have your cheat sheets, so consequently, when you get over there and start doing these things, you got the numbers in your hands, so you don't have to guess at what it's supposed to be. There is one thing I do want to point out. I can't make bad numbers. So I can't make bad pick numbers or whole numbers. Okay, so consequently, if you have something that is related to the burner or the pilot, in addition to you telling me what's wrong with it, I want you to give me the pick numbers and the whole numbers, or the energizing numbers or the whole numbers, whatever you want to call it. Okay? Because I want you to know that you need to know that and how to get it. Because in the field, you're going to need that. Okay? So anytime you have a burner problem or pilot problem, I want numbers. Okay? Even though that's probably not what's wrong. Okay? Okay, moving over to the SIP Profilin 2. Before we all start off, I have no pilot on this part. Check your IRC, and that's the module, and check the LED light on the far right-hand corner. 1 blink means you have low batteries, 2 blinks means you have a parasitic flame, and 3 blinks says it's in lockout. Okay, does anybody want to hazard a guess on what a parasitic flame is? Okay, let me tell you what it is. Parasitic flame is when the module is saying that there is a flame at the pilot, and there isn't. Okay? 99 times out of 100, if this happens for you, you change the end-out pilot assembly. The 1% that doesn't fix the problem, in that case, they want you to call SIT. So, if changing the pilot assembly doesn't work, pick up the phone to SIT. So, all right, so that's that. So error codes, we just talked about 1 blink, 2 blink, 3 blinks. If I want to reprogram, I don't think that's what that is. If I don't have any lights and the thing is in lockout or have low batteries, check for power to the IRC. Make sure that 3.5 amp fuse is not blown. Okay, and Other than that, contact the manufacturer for IFC control. Still the same problem, new spark and hood, and the model is locked out. Remember to turn off your control device. If you want to control this here, it's 30 seconds. I still have that on there because this is older stuff from SIT. Now newer stuff says 2 seconds. If it's locked out, turn the transmitter off for 30 seconds. The new one says 2 seconds. If the transmitter is off, turn it on and wait about 30 seconds. Okay, in the manual mode, this is again resetting the IFC. In the manual mode, using down arrow, lower all the way down to the off position, wait 2 seconds, and move the arrow back up on your remote control. Parasitic flame tube links, like I said, that's going to be a replacement of the pilot assembly or a phone call to SIT. To reset the IFC from lockout, that's taking it all the way down again. Wait 2 seconds and bring it back up. So that's just telling you that. Okay. So my remote kind of looks like this one here. My function for down and up is in the middle, and my on-off button is in the top. And the one that I do not have circled is my mode button. So the very bottom button there with the circle on it, that is my mode button. The big middle button is my big middle button is my up and down arrow, and the top one is off on. That's auxiliary remote control from my remote. That's a receiver for it. Most of them do not have that, but that is an auxiliary one. Okay, to program the transmitter and the remote control. Make sure that your rocker, that's the on-off rocker wire that I showed you, the green wire that is the farthest to the left-hand side on the bottom part of the module. Make sure the rocker switch is in the off position. Okay, so that means if that is jumpered, make sure your remote control is in the off position, or disconnect one of the wires. Okay. Got to go over to the right-hand corner on my IFC. I'm going to push that red button, and I should hear 3 beeps out of here. Okay, once I hear 3 beeps, I pick up my, well, I guess if I don't have any beeps, push button, I don't have any beeps, I make sure the batteries are good. If the batteries are good, replace the module. Okay, after I hear the 3 beeps, pick up your transmitter, and push the on-off button, and you should get 4 beeps out of that. Once you get 4 beeps out of that, there's communication between the sender and the remote. Okay. If no beeps, verify the batteries are good. If they're good and it's still not transmitting on, you need a new transmitter. Okay, so there's the red button I was talking about. Over there is an on-off switch. If there's a jumper wire there, remove one side of the jumper wire. Okay. Okay, now the problem is we're going to go through the same things we did on the other one. The pilot night light. We're going to go through the same sequence. Okay, the pilot light. Okay, all that stuff is the same as the millivolts, so I'm not going to talk about that. I'm going to go to this. Okay, I'm going to do the exact same thing I did with the DFC. I'm going to remove the EV1 wire from the orange wire from my valve. I'm going to check for continuity back to my module. If I have continuity there, my wiring harness is good. Okay, while that's removed from my valve, I'm going to check the ohms of resistance and look at the ohms of resistance on the IFC. The other one was 340 plus or minus 20. This is a specific number, 331.4. Okay, so they don't give you any variance or anything else, and quite honestly, I have not seen any huge variances on this. I did see point variances, but I have not seen 330 plus 5. Okay, It's usually 331.2 or 0.6 or something like that, so it's real close to that number. After I verify that my coil is good, I'm going to go over and I'm going to put my EV wire back onto my connector, male connector on there, and I'm going to be checking for voltage. Again, here my voltage is different than what it was for the DFC. Here, the thing says 4.29 volts, okay? And it's pretty specific, 4.29. Can it be higher than that? Sure. Can it be lower than that? Probably not, okay? And here again, SIT says it's going to be 2 seconds before you see the whole voltage. Not so. It just happens split second. If you're not watching your meter, you're going to miss it, okay? And on the whole voltage on this, again, it's a little bit higher than what the other one was, the DFC was. This is 0.94 as opposed to 0.5, okay? And again, with the IFC, it's always dadgum close to 0.94, okay? So again, the same rule holds true. If I have voltage there and the burner's not coming on, the pilot's not coming on, valve's bad. If I don't have volts there, my module's bad, okay? And there's just diagrams for that. There I'm testing my coil, and I'm supposed to have 331.4. Here I'm getting 331.5. So it's just a nick over what they say. Oh, and here's something I want to point out. I'm glad this picture's here. Here's my ground for my valve. So it's right above it. It's kind of hard to find, but it's usually a yellow, black, yellow, blue, yellow, green wire going to that, and then to ground, or back to the module, okay? So that's the ground for the module. So, again, I checked ground to the module, but just touching the valve and the base of the fireplace, okay? So that's testing my, I don't have to touch that ground. It could be any place on the body of the valve, okay? So as long as I'm touching the orange probe and ground, that will give me a reader, should give me a reader, give me a read. Just so happens on this one, I'm touching the ground for the valve. Okay, here I am testing the voltage. This is a better picture of that ground wire here is attached. You can see it's a yellow-green in this case. And SIT uses that a lot, uses yellow-green a lot for their grounds. Okay, here I'm testing for voltage on that, I'm getting 4.29 volts. That's what they said I should have, 4.29. So it's right on. The next one, I'm doing the whole voltage, and I'm getting 0.94. That's exactly what they said I should be getting. Pilot flip, but the electrode keeps sparking. The same procedure. Going to follow the same procedure. Going to disconnect the wire. I'm going to check for continuity top to bottom. Okay, I'm going to make sure that. Then I'm going to do all the stuff that I do for millivolts. Make sure that the flame is not, excuse me, flame is not smothering and blowing off the sensor. Okay, check for the cracks, blah, blah, blah. I'm not going to go over that stuff. Oops. And the last thing I'm going to do there, oh, that's keep sparking. Geez, sorry guys. I'm trying to get ahead of myself. I missed one here. I missed where I'm checking the spark igniter. So now the pilot flame is lit, but it continues to spark. Check continuity there. This is pretty simple. I check continuity. If I have it, the wire's good. Okay, next thing I'm going to do is I'm going to check it all the way up to the end of it. If that's all good and it's still not sensing, my module's bad. If there's nothing there, then my sensor's bad. Okay, no gas burner. Again, the same procedure. Okay, I'm going to disconnect EV2 wire, check for continuity on it. Then I'm going to check for my ohms resistance, and my ohms resistance is gonna be 331.4, okay? Then I'm gonna put the thing back onto the terminal, check for voltage. Again, it's 4.29 and 0.94, okay? So, and these are all DC volts. So ohms resistance, and there's checking for the hold voltage, again. Okay, SitPro Flame 2 has this in their name, okay? Burner flame remains on, okay? It does not have that in the DFC control, okay? But it does have it in the IFC. So if the burner remains on, and it should go off, verify all your electrical components are properly connected. Verify the flame sensor is clean and being engulfed by the pilot flame. Verify the pressure is good, and if voltage is present if voltage is present at the valve, and it shouldn't be there, you have a bad module. If you don't have voltage there and the burner's on, it's a bad valve. Okay? So again, it's just a process of elimination in your head. If I have voltage there and it shouldn't be there, it's a bad module. If I don't have voltage there and the burner's on, it's a bad valve. Okay? Okay, this is something new that we didn't look at before. This is my flame doesn't modulate. So now on my IFC, I have those 4 probes, I'm sorry. They go up to my flame modulation. So what I'm going to do with that, verify that my orifice is clean and properly sized, and then I'm going to go over and I'm going to start checking the ohms resistance on it. So I'm going to pull the controller off of my module, and I'm going to put my 2 probes in from my multimeter. I'm going to set my multimeter to the ohms resistance. And I put 1 probe on my yellow-orange, I think it's yellow-orange, is it not? Yellow-orange, and the other in the brown-black. And when I do that, I should get 25 ohms, about 25 ohms of resistance. If it's significantly higher than that, I got a bad modulator, okay? So I can change the entire modulator on it, okay? So this is what I'm talking about. You can see here, barely see here, the yellow and orange wire are coming in here, and that's to the one side, brown black is coming over on the other side. So my probes are going to go on the first 2 terminals of the Molex connector. So as long as I'm close to the 25 ohms, I'm happy. If it goes significantly higher, I'm going to be changing. There's a couple other things because this is an integrated module. I may have fans or lights or combustion fans on it, okay? If my fan doesn't come on, I want to make sure that the on-off switch is in the on position. Verify that power to the outlet for the fan plug. And the way I'm going to do that is I'm going to check the power coming through the top of the module to the 2 probes, okay? Verify the remote does not say off. Verify your electrical connections, make sure that that's pressed down onto the probes. And if it's possible, unplug the fan and drag another 120 to that. I never do that, to be honest with you. I mean, this comes from SIT, and that's what they tell you to do. But I go up there, and if I have power to my wires going to the fan's bad. You know, I don't do this last one. I do not drag an extension cord over to it to test my voltage.
Here, you can go get more of these. I got a whole bunch of these. I don't know how many people need.
Okay, well, I'll pay you for them.
Yeah, no big deal. But
How many people need a thumb drive?
so I can get one.
Well, they're all from the same company.
Okay, so 1,
Okay,
2, 3, I'll shoot that.
That'd be fine.
Sure.
Is it the same drum that you gave us yesterday, that's plugged in?
Yes. If I can drive, I'll copy them at lunchtime.
Okay. Yeah, that'd be fine. I'll just get you more.
Okay. Yeah.
There's 3 of them, and I'll get whatever.
So we have 7 different companies here.
One representative from each company, right here. Yeah, there's 7.
How about that? Okay. I'll be happy to pay you these. I'll be happy to pay.
I'll let you take a mistake.
Okay.
There you go.
Not a Chris and Pitts. Not a Chris and Pitts. I beg your pardon? Oh, you'd have to check the fuse. Top. The entire top of the, yes, you're absolutely right. It controls the entire top of the module. So if the fans don't work, the lights won't, not gonna work either, nor is the combustion fan. Okay, so yeah, this came from SIP, and it does not say check the fuse, but yeah, just check the fuse, because that controls the whole top of the module. Good catch. Okay. Okay, so that's the fan. Like I said, if I have voltage to those probes going off from my fan, if I have voltage there, I'm going to drag another wire to it. It's a bad fan. You know. And the same thing holds true with the, there's where I'm touching it. If I have voltage at that point right there, and my fan's not coming on, then it's a bad fan. Okay? And the same thing holds true when I'm checking for the lights. If my lights aren't on there, make sure the on-off switch is on. Check for, the bulbs might be bad, and that happened to mine. That's why I don't have any lights on my prop anymore. Used to have one, but I took them off because I got bad bulbs and broken wires and all kind of stuff. So you gotta do the same thing as what you did the other one. Make sure you have voltage at the IFC going over to the lights, and they're gonna say about dragging the thing over again. So I'm gonna test it like that. I'm not gonna pull the extra cord over to it, and I'm gonna try the lights. Okay. So as long as I have voltage at that terminal, at that block of terminals, then the device is bad. Maxi 12 GB60, a little bit different. Okay. I'm not going to talk about the startup sequence because I have it on a video. Okay. So rather than talk about that, I'll just show you. Right off the bat, one thing I want you to look at here is watch where he puts his fingers. He's going to put the finger on the off button and on the big flame. Okay, so off button and big flame is what you use to turn it on. Now, does that make any sense? Why would you hit the off button to turn it on? But that's their process. So here you go again. Oop, let me go backwards. So the first thing that happens, the dial goes all the way to the off position. Notice the pot is not lit yet. Now when that thing clumps inside of the valve, that's my solenoid. When that must be on a timer, so when that clicks, then I have gas going to my pilot. Now my thermocouple is being used, sending current back over to my receiver. Now that there is the opening of my valve going to the gas, and gas goes to burn. So this is the interior of the valve, and you can see the circuit opening on that. So like I said, theirs is a little bit differently. Theirs is a little bit different, because they have the thermocouple on it as opposed to the other, controlling device. Okay, now, on their slides, I included all of their slides, everything in Maxitrol gave me. So, this seems to run on forever. So I'm gonna have to go back and kind of call some of these out. Motor is not turned. It may be that my receiver and my transmitter are not talking. So what I'm gonna do is I'm gonna go over to the receiver and I'm gonna push on the reset button. I need something really small to get into that hole. Typically a screwdriver will not fit in there. So I'm gonna have to find something that's gonna go into that hole, push the button in there. When I hear 2 beeps, within 20 seconds I have to pick up the transmitter and press the down arrow on the transmitter, and you should get a beep out of that. When you get the beeps out of it, get 2 beeps out of the receiver, 1 beep out of the sender, and once you get those 3 beeps, then they should be talking to one another. Okay? So make sure that it says manual there. Make sure the battery icon indicates the batteries. Okay, so again, I'm going to push in through the reset that, get 2 beeps. Within 20 seconds, pick up the transmitter and push the down flame or down arrow, whatever you want to call it. And when you do that, you should get 2 beeps out of that. Once that takes place, the system is coordinated. Okay, after you do that, you want to check the battery. The motor is still not turning. You might want to check the batteries. Look at the position of your antenna. I don't know if I'll have to reposition or not. Just make sure it's positioned so that my receiver and it can see each other. Okay. Verify the receiver and the transmitter are operating properly. Okay. Check for wiring damage at the valve, and if I have damage there, replace the wiring harness. And they say this is something that Maxitrol includes in all their paperwork. Says check for bent pins under the Molex connector. I don't like to remove the Molex connector because that increases the chances of bending pins. So I don't like to do that, but I mean, if you have to, you have to. Okay, that's my battery pack. So, and it should be 4 AA batteries. Should have at least 5.8 volts of current coming into that thing. And that can go from there to ground, and I should be able to read it. Okay, I think there's a video on that. Let me see.
This is an Maxitrol DV60 system, and we're going to check the battery voltage at the receiver. So what we're going to do is, in some cases, you might actually have to remove this white Molex connector. So we're going to gently pull this Molex connector off, get it out of the way, and that's going to expose 5 with a small pins. What we're going to do is plate, we're going to ground out our block wires on the chassis, and then we're going to take our rotor bit and place it right on the left hand. You see that the left hand rotor, we're going to touch it to it, and you see that our voltage meter, which is set in DC volts, is 6.27.
Okay. So that's testing the voltage here. Next, just telling you how to do it. Okay, there is the antenna that I was talking about. You can take it out of the little snap things that they have there to hold it in place. If you do reposition the antenna for whatever reason, make sure it doesn't get over by the spark igniter. Because if it's over by here and over here, then this can impact the antenna. So it's best to keep that away from that. You can see they've already removed the batteries from this one here. Okay, this is my Molex connector at my valve. Okay, so that's the one coming from my receiver over to my valve. Okay, make sure that that's firmly in place and all the wires look good. Okay. Okay. here he's gonna be checking the voltage at the, I don't know, this looks like maybe me, checking the voltage at the, receiver.
Because I'm receiving the thermocouple, so my thermocouple is coming in here. It's a red loop from the wire, that's why I'm gonna raise it here, coming out of the rubber block, going over to my receiver with the red loop at the receiver. When the yellow loop coming out of the receiver, when it gets over to my interrupter block, is black. So when red loop on it coming out of the receiver, black wire going over, black loop, over here on the wire at the interrupter block. Okay, so I'm behind that black wire, and I'm going from that black wire to ground, and I'm at 11.5 volts of electricity going back there.
So that's
what the remaining 5 volts. So I'm up at 11.5 volts, so we're good to go. So I have enough voltage coming back to my valve, keep my valve open.
There's information there that we need to know, but, it's not everything we need to know for right now, okay? What I was doing was just checking the voltage out of the thermocouple, but then I took it all the way through the system, okay? At this point here, at this black wire here, underneath there is where I was touching, to the valve body, I only need 5 millivolts of current because I've used a ton of it right here. Coming through the interrupter block, here's my thermocouple coming down, attaching to the interrupter block. Okay, here's my red wire coming out, coming over to my red wire. What crap is it? I don't even see it. I don't know what that green wire is. I don't know, maybe the green wire is the yellow wire? I don't know, this black wire here is I don't know, I can't see that. I can't see that picture good enough. I'll show you on a different picture, okay? Because down there, it's kind of hard to look. Manual ignition, there's a video on this, so we'll look at the video. Maybe I'll get a better shot of the receiver and I'll show you what I was trying to explain on that last one, okay?
This is an Accuco G60 system. We're going to do a manual lights. For this one thing to pay attention to, make sure if you have little microscopes like this, make sure the I is pressed in, I for ignite, O for off. You're going to turn this oval knob right here. It's going to move from the on position up to the end for manual. And there's a small screwdriver, anything you can insert into this hole. And then you're going to press in inside it. Before you press that in, put your flame up to the bottom, press in, ignite, bring flame, bring the gas to your flame. You're going to hold it in for 10 to 15 seconds or so. You can see on the multimeter that we are generating power using the thermocouple. It's going up, it's about 10 millivolts right now, millivolts. Is holding, pilot's on, still generating no power. We currently have a pilot lit, but we still have the oval knob in the manual position. When it is in this position, the burn will not come on. I can take the round knob, which is currently in the off position, turn all the way on, the flames will not come on over. But if I turn this on, the round knob on, and then come down here and set the oval knob and turn it to the on positions as the air is coming on. Flames will come on. Coincidentally, if you turn it from the on back to in, the flames go off. Okay.
I don't think I have anything to add to that. I can't think of anything. That was a pretty good run through on doing it manually. Oh, there is one thing I want to talk about. Let me go back here. I'm going to the on-off button he was talking about. This one here. MaxiTrol will put that anywhere that the manufacturer, the appliance manufacturer wants it to be. So on stuff coming from Peterson, that bugger is hidden underneath my receiver. So you have to look for it on the receiver for the Robert Shaw controls. Because they can put it anywhere. This one here is readily easy to see, readily available, readily accessible. But like I said, some of the on-off switches on Peterson are kind of hidden underneath the receiver. As a matter of fact, that is what I have on mine. I have a Peterson set of controls, and it's tucked underneath the receiver.
Is that,
This is just going through everything that we just talked about. So like I said, that you'll get that on the handout. Okay, no spark. Okay, on this one here, what we're going to do is make sure that we have continuity in our wire. And then the next thing we're going to do is we're going to jump over to number 5, and we're going to put a jumper on there, put it within an eighth inch of ground, and turn it to the on position. Okay, if I don't have any spark there, the receiver is bad. If I do have spark there, then my spark igniter is bad. Okay, but I did not color code these yet. I need to go ahead and do that. Some of these things here are the same things that we do on millivolts. Okay, now I have no pod flames, but my spark igniter continues to spark. Okay, if it's running on battery only, test batteries for output, I should have a minimum of 5.8 volts of current, VDC current. When you replace batteries, remember to be careful when you put them in so you don't reverse polarity. Check the antenna wire to make sure it's not over by the spark igniter. Okay, check pressure to make sure it's where it's supposed to be. Now, I want to verify that the red thermocouple wire is placed on the left-hand side of my receiver. Okay, and the yellow wire is on the right-hand side. I said left-hand side. Make sure that the red wire is on the right-hand side of my receiver, the yellow wire is on the left-hand side. If those things are reversed, somebody did that on purpose, because there's different size C-clips on the red wire and on the yellow wire. Yellow wire is kind of narrow, the red wire is kind of wide. Okay? So just make sure the red is on the right and the yellow is on the left. Okay? Now you're going to test for millivolts at the red terminal, and you're going to put the one lead from your multimeter on the red terminal, second lead to ground. Okay? On this one here, MaxiTrol allows you to take the millivolts all the way down to 10. Okay? So because of passing through the interrupter block and all that, yesterday we talked about 15 being the minimum. They allow it to go all the way down to 10 because of their using somewhere for the wiring and the interrupter block. Okay, so it should be between 10 and 15 millivolts. If it's less than 10, then change the thermocouple. Okay. Okay, so up there, the red wire I'm talking about. So you're going to touch the red wire. Oh, this is talking about reversing the one. Red is always on the right, yellow is always on the left. I'm going to be testing millivoltage at the red wire to ground. Okay. So that test at the ground, and that should be between 10 and 15 millivolts of electricity. Okay. Now, if again I have no pilot flame, okay, the next thing I'm going to do is I'm going to go over and I'm going to measure my yellow wire to ground. Okay, when I do that, it says about 5 to 6 volts. That's contradictory to other slides. Now, like I said, I got all these slides from MaxiTrol, so I'm not making anything up on this. So they say 5 to 6 millivolts out of the yellow wire. That contradicts the next slide. Okay, if power is good with the receiver, bad power out, check for batteries, loose connector, or replace the receiver, okay? But here, this one here contradicts this one, because the first side said 10 to 15 volts. Okay, now this side says that I'm going to test the current between the red and the yellow. And this one says that I should have no more than a 3 millivolt drop between the red and the yellow. Well, if I have 10, that takes it down to 7. This says 5 to 6. So I should never get 5 to 6 here if I have only a 3 millivolt drop. So again, this isn't my stuff, this is from Maxitrol. So if I have only a 3 millivolt drop there, then my receiver's bad. Okay? Go ahead and make sure the connections are clean. Okay? So that's for the pilot not coming on, but it continues to spark. Okay? So in that case, what's happening on this one here is I'm not getting millivolts to the yellow wire in the proper amount to go back over to the valve. At the valve, and I'll show you this in a close-up here for a while, at that point, coming out of here, I can have as low as, what did I say? Geez, my brain just went dead. 7, low as 7 on this one here, but over at the interrupter block, all I need is 5. Okay, so they compensate for loss of voltage throughout the entire system and advising us of what the minimum voltage is supposed to be. So thermocouple voltage, motor voltage is low voltage to begin with, so they compensate all of that with the millivolts and loss of voltage through the wiring and through the interrupter block by allowing us to keep dropping the voltage. So from the time it enters into the red wire to the time it goes all the way back over to the valve, I can have as low as 5 volts of energy, millivolts of energy. Number 8, make sure that the thermocouple interrupter block is not over tightened. The very first time that I worked on one of these, I destroyed the valve and the interrupter block, okay? Because I over tightened the interrupter block into the valve, okay? I put it in, and I did what I would do with a thermocouple, put it in figure tight, moved to the quarter turn, and when I moved to the quarter turn, I over tightened it. Over tightened it, I ruined the interrupter block and consequently the valve. So if you over tighten that thing, you not only have to replace the interrupter block, but also the valve. Say, and one of my classes, I guess, that happened in, and again, when I talked to Maxitrol, they sent me an interrupter block, put a new interrupter block in. I needed a valve also. So if it's over tightened, you're going to be buying a new valve and a new interrupter block. Okay. If you
What is overtime? Is it just slow? How much sugar do you play?
I do it finger tight. After I bought that valve and interrupter block, I go finger tight. And one of the other things that I do, everyone, is if my interrupter block is already into the valve, which it probably will be, when I'm putting the thermocouple into the interrupter block, I always back up my interrupter block with a wrench. So that when I do the quarter turn over here, it is not doing a quarter turn on my interrupter block. Okay? Because like I said, quarter turn, from my experience, was quarter turn over tightened. And what happens is there's a little plunger in there, and for whatever reason, the plunger gets flattened. And when it does that, it damages the valve. So be careful of that one. If you're going to mess around with the thermocouple, and you will be here, just make sure that you back up the interrupter block with a wrench when you're putting the thermocouple back in. Okay? So here I'm testing for millivolts at the receiver, or is that the valve? It says valve, but why am I showing the receiver?
This is a max utility existing system, and we are testing the thermocouple circuit on here to see how much voltage the thermocouple circuit is generating. First and foremost, you make sure that your voltmeter set on the DC voltage, which is the little straight line, the curving one. You also need to make sure you are setting millivolts, not volts. So you have to refer to your meter for that. What we're going to do is we're going to ground out to our chassis again. And all we're going to do is take our red probe and put it on the red terminal. And right now that reads about 14.5, which is good. You're looking for somewhere between 10 to 15. And I also need to make sure to tell you that you have to have the pilot running at this point. It has to be touching the thermocouple.
Okay, so that's the voltage from the thermocouple back to that. Remember, it needs to be 10 to 15. Now, if I touch red to yellow, I can have no more than a 3 millivolt drop. So that means that coming out of the yellow wire, I need a minimum of 7 millivolts coming out of that. I'm sorry. Yeah, 7 millivolts coming out of the yellow wire, and out of the interrupter block, that goes down to 5. Okay, and we'll just keep working the way through the system here. Okay. So this one is the in and out.
What I do is I'm going to check the difference in the voltage between the voltage coming in and the voltage coming out of the receiver. And this should not be any more than 3 volts. I get my 16 volts. I'm going to touch this one to the ground. On this I get 15 volts, so now we lost 1.9 volts between my incoming and my outgoing on the valve. So I lost 1.2 volts of electricity between incoming and outgoing. I should never be any more than 3 volts of a drop between my incoming and my outgoing.
So that's the red and yellow. Okay. Okay, so there's a, what was I trying to show you before? She's already brain dead. Can't remember already. So that's my red one coming in. That should be maximum voltage on that one, 10 to 15 volts. If I don't get more than 15, that's bonus. Okay. Okay, so 10 to 15 on that. When I measure the yellow side, that should be somewhere between, I don't know, 3 volts, 12 and 10, 12 and 7, 12 and 7. Okay. So it shouldn't have more than, see, geez, there it says 5 millivolts. It's the 3 millivolt drop. Okay. This is this is the problem using somebody else's slides. These are from, like I said, from Mexico. Okay, so I'm using my remote. I have no tone and no ignition. Replace the batteries on the receiver and reprogram the remote. Okay, if I have 1 5-second long tone, okay, chances are it's going to be number 1. The on-off switch is in the off position. Okay, if it's in the on position, you want to look for a loose wire or bent pins, and then this is one of the things that drives me absolutely bonkers with Max Control. They say it's either a bad receiver or a bad valve, but they don't tell me how to distinguish between the two. So I can't tell you. I can't tell you how many people I asked over at Max Control to define it for me, so that when I'm teaching class, I can say, this is what we do to define this bad receiver, this is what we do to define a bad valve. Nobody's given me an answer, nobody. So
So you're replacing both?
That's exactly what I said. Because I have no way of isolating each component. Now, I do know that if my voltage coming out of the module is greater than 3, then the receiver is bad. But they don't tell me anything about the valve. So, anyhow. The pilot stopped sparking, but receiver made several beeps. Check for the ground lug. The ground lug is up in the upper right-hand corner of the valve, and it looks like a screw that's holding the valve together. Okay, it's placed in the upper right-hand corner. It's fairly good size. Want to make sure that that is clean, so you can take that out. You can't brush that down with a wire brush. You can clean underneath that with the wire brush also, and put everything back together. Okay, so that's my ground lug on my valve for the GB signal. Okay, my ohms resistance should be less than 600 ohms. Okay, so just remember, just pull that out, clean it up, clean everything off, put it back together. When you test it, shouldn't be any more than 600 ohms of resistance. No gas to the burner. Make sure your knob is in the on position, not in the manual position. Make sure your valve is not in the pilot position. Make sure you don't have low end pressure, and if all of those things are okay, you got a bad valve. Okay. Oh, that's pretty much talking about everything that we do for the motor system, except the one that is in white. Make sure your electrical connections are correct. Again, both of those would be common ones. This is startup voltage on this, and I think it's a video again.
This is the Max Utility System, and we are testing the startup voltage, also sometimes called the peak voltage, kick voltage. This is a voltage that is required to ignite the fireplace or ignite the appliance. Typically, in this case, the voltage is coming from the batteries. Okay, so what we're going to do on the Max Utility is we're going to hit the red button and the top plane button to start the ignition sequence, and then we're going to go over and measure our voltage on the yellow side. Grab on the black again, put your red probe on the yellow. You want to put a clean right there. And it's a really quick one. The drum will be for about 5 millivolts. We're sitting at 6.5 right now. So we were good.
Remember on startup, the startup power comes from the batteries. If you don't have batteries, it's coming from your AC power coming in. So anyhow, right there, I'm only looking at 6 volts of energy to start the process going. After the process is going and my thermocouple is being heated, then I'm getting power back to the red one, and then all those numbers that we just talked about come into play. But startup is only 6 volts. Okay, the interrupter block is right there at my fingertip. I think it's mine. It looks like a yellow Jerry shirt in there. So interrupter block is right where my finger is, and I think I'm going to be checking energy there.
Okay, here's what's important about this. If you over tighten this into the valve, okay, it does not work. It won't work. And what you'll end up doing is buying a new valve and a new interrupter block. So do not over tighten the interrupter block. When it goes into the valve, if you get some of your fingers, that's fine again. That should hold just fine. The other thing I think I just remind everybody, when you put your thermocouple in here, everybody talks about thermocouple being tender tight quarter turn. Just remember to back up the interrupter block with a wrench so that when you're tightening up the thermocouple with your quarter turn, tender tight quarter turn, you're not going to be turning the interrupter block. So make sure you're tightening the thermocouple into the interrupter block, but you're not pushing the interrupter block into the valve.
Sorry, I thought that was testing voltage. Oh, there's, I guess maybe I don't have a video for that. This is what I was talking about at the valve. Okay, this is my line that's going out to the red part of my receiver. this is my yellow wire coming back from my receiver, okay? So on this one here, I'm not gonna slide that all the way on, gonna put my probe in behind that, and I'm gonna touch the ground of the valve. And at that point, I need a minimum of 5 millivolts. Okay, I can be higher than that, that's my minimum, okay? So, that compensates for loss of voltage through the entire system. So it starts out at 15 millivolts, and by the time we get back over here, I need a minimum of 5 millivolts. Okay? So if I have that, that's my minimum number. If I have that, then the valve is supposed to work. If it doesn't, then the valve's bad. Talked about that enough. That's the grounding screw. He's talking.
This is my ground screw, okay? If you have problems with the ground, it's okay to take this screw out. This is not holding anything together. It looks like it's a screw to hold the valve together. If you look at it closely, it's not holding the valve together. This is a ground mounting screw. So if your ground is bad, you can pull this out, take a piece of memory card, piece of sandpaper or whatever, shine up the back side of the screw, put it back into place. So what we're going to do is we're going to take one of our probes, and we're going to go over to the yellow lead on the wiring harness, sneak down behind that thing, and then come over to the grounding node onto the flat, and you can see the resistance on that is all the way down to 0.1. So we're good to go. Everything is good on the ground on that.
Remember, I can have up to 600 ohms resistance there. Shuts off, the valve shuts off between 10 and 60 seconds, and it does not operate manually. In most cases, it's number one, it does not have enough voltage coming from the thermocouple. We've already talked about how to measure that, so I don't want to beat that to death anymore. So it's either a bad thermocouple, inlet pressure, and if those are good, it's a bad valve. Dropout time less than 15 seconds. This is for the thermocouple to the yellow probe. Less than 15 seconds, it's a bad valve, and more than 15 seconds, it's good. Okay. Kenneth is going to show you what to do here.
This is an Actico G60 system, and we are testing the dropout voltage on the valve. This is testing at what point the valve releases the magnet inside so that it shuts the gas off
Testing the valve
to compliance. We have a lot of do this. However, in the way we was a machine want to cut off the gas flow to the valve. And there's the voltage. Currently, we have a voltage of about 14.1 being generated by the thermocouple. We also have a timer here next to it, but which you can actually measure the time that it takes to click, which is the reset, and that'll tell you if this the valve is good or bad. So I'm about to shut it off, and I'm going to hit start. As soon as we shut the gas off to the unit, I will then hit stop on the timer as soon as I hear the click. So, and the gas is turning off. Now hit start. You can see the millivolts dropping because we have our meter set to millivolts. It's dropping. I have my red probe on the red terminal. It's 3.4 is what the reading was. 22.4 seconds on the clock. Both of them so in a good range. Ideally, you will have it would reset at 2 millivolts, but anything below 3.5 is acceptable.
Okay, so if it's 15 seconds drop, 15 seconds or greater, it's a bad valve. If it holds open for more than 15 seconds, it's good valve. Power system continues to spark, it's bad receiver. Okay, that takes us over to the Dexons. Okay, first thing I want to look at is the Dexon GV60, the GM6. GM63V, I'll get it right yet, okay? Okay, this is George Suzuki from Dexon. He's going to be doing a couple of things here on the video.
And we have in front of us is the battery-powered IPI Dexon 6K emission control system. It works with 4 additional components, which is going to be the battery pack in order to supply the power. It operates off of 2 E-cell batteries. The pilot assembly offered by Dexon connects with natural and additionally NMP. The 6003-3B valve that operates together with the 6K module, and additionally you will need a drag contact switch or a rubber switch in order to turn on and off. The wire harness shown here has an 8-pin Molex connector. From right to left, it has a black and a red wire that goes to the battery. 2 brown switches that go to the dry contact switch. Green, orange, and black wire goes to the valve, with the green being the power for the main burner, the orange being the power for the pilot burner, and black being the ground for the entire system. On the left, you see the pilot assembly. On the pilot assembly, you see the flame sensor and the ignition rod in the center. Both the gaps for the ignition rod and the flame sensor should be about 1/8 of an inch apart. Additionally, on the 6K module, the ignition control module is labeled I for ignition and S for the flame sensor. The orange wire from the pilot assembly should be connecting to the I for ignition, and the flame sensor wire, which is labeled in the black wire, should be connecting to the port that's labeled S on the 6K module. If the Dexon ignition control module is connected correctly, you should be able to hear this spark immediately at the pilot assembly as you turn on the system. All you need to do is turn on the switch, on the rubber switch, and you should be able to hear a spark immediately. If the system is working on a breathing AC power supply, then the battery pack to the 6K module should not be connected. Please note that the 6K module can only work with a battery or only work with a 3-volt AC power supply. If you want to work with both 3-volt AC power supply and also the battery pack, a 5K module will be required in order to operate the system.
Okay, all of my stuff back here has that 5K module. So I can operate my prop off of either power from AC or from DC power. So I'll show you what that looks like. It's tiny little thing, it looks like a relay. Okay, it's probably no bigger than an inch and a half square, and it's just a tiny little thing, but that has to be on if I'm going to hook up both battery and external power at the same time. The other thing I want to comment on, one of the things that I like about Dexon is when it goes to the on position, it starts sparking immediately. It's not like SIT. On SIT, you turn the thing on, and you might wait 10 seconds before that thing decides it wants to start ticking. Okay, so Dexon is immediate. As soon as you put that to the on position, it's going to start taking off. Okay, on the SIT, just be patient. Wait for a little bit of time, make sure that it's going to start to click, okay? And mine back here are no different than what you find in the field, okay?
Go back and start off to the beginning of the beginning.
You want the video playing?
Yeah, hit play because he lists everything that's in that system.
Okay, and we have in front of us is the battery powered
That'll work. Take it.
You got it?
Dexon.
Okay, so on this side here, he's going to be checking voltage through the adapter. So through the transformer adapter over to the valve for voltage, okay? You'll notice that it's not a plug-in type adapter on this. You only have plug-in types on the 6 volts, okay? So these have 2 terminals at the end. It's going to go at the bottom 2 terminals on the module.
To verify your cable AC adapter is working properly, you will need a 110 volt outlet, power adapter, additionally the multimeter. First, you need to set the multimeter to AC voltage, which should normally be represented with a V with the smooth line voltwords. You'll want to insert your probes into the power adapter. Make sure when you perform this task that the power adapter is disconnected from the outlet. Gently insert the probes in between the sleeves of the power supply. And once you connect the device, you should be able to see the power should range between 2.8 up to about 3.5 volt AC. If you can observe that, your power supply is working properly.
So I'm going to stop right now and I'm going to ask you a question. Where are you going to set your multimeter? If you're checking the pick and hold on pilot or burner for SIT, where are you going to set your multimeter? I'm sorry?
DC.
DC. Where am I going to set it for Dexon? AC. Okay, so I'm getting AC through my transformer. My module is going to be working on AC current. So when I'm testing back here, make sure that you're on the right scale. Okay, and when you're testing in the field, make sure you're on the right scale. That's my battery pack over to the left. It's 2 D-cell batteries, and on the right side is my transformer. Okay, so through my battery pack, I should have up to about 3.4 down to about 2.8, and on my adapter, it should be 2.8 to 3.5. Okay, what George is going to do now is going to be testing the battery pack at the Molex connector. Okay, so this is the battery pack here. Remember, the voltage from my AC adapter is coming into these 2 terminals here. So now we're looking at battery.
What in front of me is the fully assembled SysA machine control module. In order to verify the voltage of the valve, you want to measure the voltage that is going between orange and also the black wire on that's coming from the 6K module. Additionally, you'll have to check the green and the black wire coming from the 6K module. The orange and the black wire will measure the voltage going to the pilot, and the green to the black wire will measure the voltage going to the main burner. In order to do this, you will want to set the multimeter to voltage with a straight line over it. This will identify the DC voltage. Once you have that set, you'll want to measure the orange and the black wire on the valve. And if you turn on the valve, you should be able to see 1.4 to 1.0 voltage. And once the pilot is lit, the voltage should drop to 0.2 to 0.5 voltage DC on the 6K axis. Additionally, once the pilot is stabilized, you should be able to see a voltage between black and green. I will not be able to demonstrate this on this video, but once you have the pilot lit, you should be able to see the voltage on the main burner ranging between 1.3 to 1.8 volt DC.
Okay, he's measuring DC because he's working off the battery. He doesn't have the AC connected to it. That's why it's DC at that point. No spark. Make sure you have your wires properly connected. Make sure the wiring harness is in place. Make sure your AC adapter is properly attached. okay? Check gap on your pilot hood and your niter tip. Check for continuity on the wire on your igniter back to the module. And then, what was that, what were we doing there? And then the other thing we're gonna do on active spark, we wanna make sure that the module's bad, so we're gonna put the jumper wire on the, where you've taken the wire off to the spark igniter, put one on there, go to an 1/8 inch of ground. Okay, here George is gonna be doing the 3 planes of ground. He's gonna show you how to do that.
In order to verify that the ground plane on the 6K module is connected properly, you will need the multimeter in order to check this. On the multimeter, you will want to set it to continuity, and you'll be checking the ground wire against the control module, the valve, and additionally the pilot assembly. Using the multimeter on the continuity, if there is continuity between the 2 points, you'll hear 80%. In order to check the ground plane, everything on the black wire on the Molex connector, as seen on the module here, should be connected to the belt. All the ground belt and body should be grounded, so if you touch anywhere with a probe on the belt, you should be able to hear a sound from the multimeter identifying that the ground plane is on the same level as the module. Same on the multimeter, and also touching the pilot hood on the pilot assembly. If you hear a beep on that, it will tell you that the ground plane is the same on both the pilot assembly, which is on the valve, and additionally the 6K module.
So he talked about doing the module to ground, he didn't do that on the side. So the third test is module to the chassis. It's no spark in pilot hood, so he's going to be checking continuity and wire to the module.
So you'll be connecting, there'll be an opening on the sensor, you're going to touch the tip of the sensor of the pilot assembly. Same thing for the ignition rod, touch the tip of the ignition rod in order to hear continuity between those 2 points. Make sure when you do the pilot assembly check that the device is not lost.
Okay, so that's just showing you what we talked about several times already. Okay, make sure that this is the where I'm telling you to take your wire off there, put your jumper on, go to within 1/8 inch of ground. Okay. Check for voltage. Check the continuity through my 2 brown wires. Okay, remember what I said earlier? I can check my voltage, my continuity at the module through the 2 brown wires. Just make sure that the system is open. So make sure that the should be checking with 1 wire removed. So I guess the 2 brown wires, you have to be careful with that because it could be going through the coil. So you need to break down 1 wire in the system. Okay, here he's checking the wall switch for continuity.
To verify that your wall switch should be working correctly, you can take the state off of the wall switch. By simply connecting the 2 ground wires coming from the SysGate system, it should be able to turn on the device itself.
Oh, that's, yeah, I forgot about
You
that.
should hear an immediate start from the system.
Yeah, so that's something we had to talk about that, so that is one way that we can check, just disconnect the 2 wires from the switch and put them together. Okay, so now we're on no gas to the pilot for the Dexon GM 6 valve. Okay, all that stuff is going to be same as motor volts. Okay, then we're going to go over here, we kind of disconnect the wire to the space connector and check continuity between the module and the disconnected wire. So this is going to be from the EV1 valve. So I'm going to take that wire loose, it's going to be the orange wire, check the continuity back to the module. So, ladies and gentlemen, I'm doing the exact same thing as I did with SIT. So there is no difference in my procedure here. Okay, So I'm gonna check my wires and make sure I have continuity. I'm gonna leave my wire off, and I'm gonna check for, ohms, coil ohms of resistance. And when I check that, I should have somewhere between, voltage, sorry. Okay, sorry about that. They doing the voltage for a test first. So you gotta put the wire back on, and then check the voltage, sneaking in behind it. Should have 1.0 to 1.4 volts for the peak voltage, and it should drop down to somewhere between 0.43 and 0.5 volts for the whole voltage. If I don't have the voltage there, my module's bad. If I do have the voltage there, the valve's bad. On the 6003 valve, to check the ohms, the resistance to the coil, I'm going to remove that flag connector, and I'm going to put one wire on the flag connector and the second one over to ground. And when I do that, I should have 40 ohms of resistance plus or minus 5. And if I'm not within that range, I'm going to replace the valve. That's the 6003B. Okay. On the 6003B, okay, now this is the different valve. This is the one that has only 4. Remove the wiring harness from the valve. Facing the harness box, the 2 pins on the right are the pilot controls. So they should be the yellow black or the orange back wire. On this one here, it looks to me like it might be yellow. Okay, so the yellow black is over there. Okay. Touch the back lead to the right pin. The reading should be 40 ohms plus or minus 5. On the